Okay, should be live here. Hi. Oops, let's not show that. Let me fix this real quick. Oh, why can I not fix the stream? There we go. Okay. Here's the plan for today. First, we're going to post the article. Welcome, RM. I promised I would post the educational article at 10K followers. So we are going to do that right now. The only thing I have to figure out, I've got two articles here. This one's 4K words, this one's 2K words. So the only thing I gotta figure out is what images we're gonna put on here. I figured I would just do this live while stream warms up, and we will go from there. And then after that, we're gonna work on drone things, most likely. So I don't know, let's just make something real quick. Guide image 5:2 ratio. So like, let's do, I don't know, what's a good 5:2 ratio? Let's do like x300, so 1500 by like 600, is that right? I was just gonna put like a basic like summary thing in the image maybe. Oh, let me also go grab the puffer fish. So of course we're gonna have him in there. We'll post the article. Shouldn't take me too long to do that. And then we will do drone stuff for the rest of today. Pufferfish PNG. Oops. There we go, there's our puffer. How's RL coming along? We have all sorts of fun stuff, man. We've got the drone end is working pretty well at this point. I think that the main thing I'm going to be working on today is like cleaning it up and figuring out if we can get like one policy, basically one policy that can do all the drone stuff we would ever want. We just have like one really, really good drone benchmark. We shall see though. That's the spirit, yeah. The one thing is I hate having to do thumbnails and like advertising type work because it's really obnoxious. So here, if you have any ideas, actually, we'll crowdsource this. Um, so I have this article, My Advice for Programming in ML. I've got this one, the Ultra Opinionated Guide to Reinforcement Learning. And we need to have some thumbnails for this. So usually I do like AI gen crap. I was thinking I would just actually, for these, since these are more educational materials, I would just like put some basic summary stuff in it. Give it a follow. Drop your X. We just hit 10K on it today, actually, which is really nice. I will put this in the chat. There you go. Why are my notifications blowing up? That's funny. Let me get into Twitter stuff here. I'm traveling and deving. Surely there's an audience for me out there somewhere. Oh yeah, it's Twitter's been really good for pretty much everything. It's gotten us a lot of I mean, business side has done well from there as well. Okay, let's see here. So what do I write? Like, I just think I go grab like the main topic points from the articles, right? Why are you making the guide image in Docs? It's not Docs. This is Google Drawings. Is Figma like actually good for like a basic editor that stays the hell out of your way? Like I'll open GIMP or something if I need to do heavier stuff, mostly. I used Photoshop before, but it's not. The web version of Photoshop sucks and I'm on Linux, so. Should I just copy all the bolded like titles? That doesn't seem great. I guess I could. Let's see if I just like start copying these in if I like what this does. Whether I like the way that this looks. Photoshop has doing since yeah, I've done Photoshop since I don't know, partway through high school as well. How's it been like to build a community in such a oh I read that as okay, non-traditional way. There doubt you along from Are there doubt from you along the way? It's really not all that non-traditional if you think about it. I've kind of just basically what I've done is I've taken very traditional credentials, and then I've done something non-traditional with them, which is a hell of a lot easier, right? Because like I've done like kind of semi indie dev stuff where I've built like this community around this very compact set of tools, but it's also for a niche specialized topic that I have, that I have a PhD in, that I've done actual academic research in for a decade, right? So it's kind of a blend. You're trying to make a thumbnail, you should try out Midjourney. Negative space and overlap summaries. Yeah, I've done that. If you click any of my articles on X, I've kind of done a bunch of AI gen crap. I wanted to have something different for this. I'm just gonna try something, you know? I don't really want AI gen crap. It's kind of funny. Like I really like all the AI stuff is cool, but I really don't like generative AI in most of what I do like, at all. In some sense, it's like the least interesting part of AI to me. At least as it is right now. I think when you combine it with way heavier RL than people are doing now, generative AI is going to be really good. But like, I'm not doing that because it's so much slower and more expensive and crap to do your RL research on Gen AI instead of just doing it in the way I'm doing it. Hi Joseph, building. Okay, I read that for a second. It's like building a computer with RL. Building an RL computer. Got a 1590. How important is CPU multi-core for model training? Incredibly important if your environments are not like as fast as our fastest environments are. My spec for my highest end machine spec that I use is a 5090 with a 9950X, 128 gigs of DDR5, and Noctua fan. Do not cheap out on the fans. I have 10, 12, something like that desktops now for RL, and the Intel build sucked. The 5090 is sometimes a very small boost above a 4090, sometimes it's a very large boost. It kind of depends on the problem. And then you're not going to notice the multi-core performance at all for really fast environments, and you're going to be hard bottlenecked on slower environments. So pretty much if you want to do anything at all that's not like million step per second sim, you are going to be very sad if you don't have cores. 9950X, yeah. So I never run out of RAM anymore. Like, RAM's never a problem for me. It really depends on your sim. Okay, it depends on your sim. CL30 versus... I don't know. I haven't noticed any. Like, I haven't done RAM timings. CL... What even is CL? Are you referring to the clock speed? Oh, latency. Huh. Yeah, I have not tested that. '64 is good. It depends on your sim. 9950 X3. I don't have an X3D. What's the X3D give you? Do cherry-picked conditions? Huh. I haven't looked at that, honestly. Like, the thing is, it depends how good your sims are, right? Like, how good are your sims? L3 for gaming? Hmm. So here's the thing. Congrats on 10K. Thank you. I'm fulfilling my promise of the article right now. I'm just making the thumbnails. So here's the thing about our sims. You want to know something really funny? I'm not even doing anything smart with like the vast majority of what I'm doing with Puffer. Like, I'm writing brain dead freshman CS level C. It's really simple. I'm not cache op, like, I don't optimize anything for caching. Well, not for that type of caching, right? I'm caching computation, but not actually optimizing for cache hits, right? I'm not doing like any SIMD optimization. I'm not doing anything. Like, literally, we could make our sims 10x faster, at least. And actually the same, believe it or not for the larger models, but for our smaller models, we could make those 10x faster too if I were doing it smarter. And it's still the best thing out there by an order of magnitude. So it depends on how much hardcore low-level dev you want to do, right? If you want to like optimize a sim for a specific chip or like a specific cache size and use patterns, be my guest. It'll be pretty cool. Maybe it gives you a big perf bump. I don't know. I'm not even doing anything on that level at all, though. And it's still, and Puffer is still as fast as it is. Which basically just tells you how crap modern programming is. Like, literally nobody knows how to program anymore. Let's bold this. Oops. Or unbold this, maybe. Let's put like a tiny little break in there. Hey, Spencer. For what's CFD, Spencer? Is it worth investing time into data structures and algorithms for us in AI field? So yes, and if you're reading this bullet point, there's a difference between knowing data structures and algorithms and like knowing how to solve tricky puzzles with them that in no way correlate to things that you actually end up seeing in the real world, right? You should absolutely know basic data structures. You do not need to know 10 different ways to apply dynamic programming. Like generally, you should be able to implement a vector. You should be able to like a list, I guess. You should be able to implement a linked list. You should be able to implement a map if I allow you to look up the prime numbers or whatever, right? But that's very different from like solving weird, tricky, unintuitive problems with them. Let me see how this looks in the article. This. Oh yeah, I didn't answer Spencer's thing. Computational fluid dynamics. Yeah, it's funny you bring that up because there's another thing I've been looking at with that. I think so for the most part, but I think it depends. It kind of depends. I think mostly yes though. We'll be sure to read the article. Where will it be available? It'll be on X as soon as I finish making these thumbnails, which will be in a few minutes. Congrats on 10K. Hello, Finn. Welcome. Did you see the thing I sent you guys? We can fly whatever drones now. I do need to ask you guys a bunch of physics, though, if you're around. Can I actually just link this to you real quick? Let me link you what I did, because I need your guys' input on this. because I'm going to be working on this today for you as well. All right, read this function here. Can you guys read this function and tell me if I did garbage with the modeling? So the goal here is that this should be able to represent basically any type of reasonable drone you can put together. Possibly with reducing pollution emissions in factories. You straight up build a sim and then move things in the sim. Yeah, if there's an agent in the loop in a sim, then yeah, that's a... And maybe we can fit something. I'd happily take a meeting on that. Oh yeah, people are really looking for this. I just posted this at breakfast. Okay. We'll have a look. Thank you. So if we can represent pretty much any sort of reasonable drone fin, then we should have a very easy time getting this working on whatever specific hardware. And yeah, don't forget the meeting later as well, Spencer, if you're still here. I use JavaScript to put temporary AI memories in browser local storage. Let's use JavaScript, right? Yeah, I don't know what that means. Whoops. What kind of hot topics would you direct your master's thesis in if your goal is to get it published and eventually do a PhD? Are you in the US or are you in Europe? In the US, you don't do a master's if you're going to do a PhD. Like in the US, you go direct from undergrad to PhD. You don't do a master's. And then depending on your program, they kind of just give you a master's along the way for the hell of it. And you're not going to get any sort of optimistic take from me at all about like the way that academic work is done in RL at the moment. Okay, yeah, they expect us to. I know it's different in Europe. The thing with, okay, here's the perspective, and I think you'll get this from the article once you read it. We had hundreds to thousands of scientists, actually really thousands of scientists, beating their head against the math of reinforcement learning for 10 years. All right, they got nowhere. They published a bunch of stuff that was almost all wrong. And the stuff that they got right was mostly by luck. The thing is that RL has gotten mostly bottlenecked on engineering, and like academia is just allergic to engineering. So even when that's the way to solve the science problem they care about, they just won't do it. So I don't really have any good insights about the scientific process because it's kind of just bullshit. Like, I can tell you what are topics that are impactful in research. I can tell you topics that are like going to revolutionize the field and change the world, but those are not the same things that get science excited, like, at all. Usually it's when you come up with some like clever algorithmic sounding thing or some like clever formula that may or may not even be correct is when people get excited in academia. Hey, Sam. I linked Finn, let me link this to you as well. I linked this to Finn already. Insights will be appreciated on the modeling that I did there. The goal is to be able to represent any type of drone we want. I have that version committed and it trains. So it trains like all the different drones that can be initialized by that function. Different sizes, different weights, all sorts of stuff. But I need to know if I modeled it correctly or not. Have a look, thank you. I'm trying to make it easier for you guys when you try to actually run the thing on real hardware. I'm gonna have to get myself a drone as well. I don't really know what to do. Technically, I have a park in California where I can probably just go take that for a bit, but I'm not gonna be able to travel with the drone if I get one. I don't know, can you just put a drone in your suitcase or does TSA go insane? Well, I'll have to get through it since I want to do my PhDs, Golden Engagement Research. Yeah, I guess the thing that's going to keep you best grounded, right? This is the way to keep yourself from going insane in academia, okay? So you think of your job as two parts. Part number one is how do I improve the field? Like, how do I genuinely do meaningful work I care about that will improve the field? And part two is how do I sell it to a bunch of bookworms? All right? Literally, that's all it is. Puffer Lib going with robotics or drones or just experiment. So Puffer is general purpose reinforcement learning. We do reinforcement learning in a ton of different areas. Drones are low fidelity control more than they are like, low fidelity control in robotics is cool with us. We're doing some stuff in this area. We do stuff in logistics, done stuff in animation, stuff in finance. Like, we do stuff in a ton of different areas. It's a general purpose. It's general purpose tech. We build out applications wherever we see opportunities. Increasing the space between the lines. Yeah, the thing is, I'm kind of worried about the. Actually, no, you're right. This will work. So I'm worried about, because like X is gonna do weird shit with the spacing. Like, because it'll automatically mess with it for mobile, for instance. Hello, Imagine. Welcome. Missed the last 2 days? Well, I was traveling 2 days ago, and I did some drone stuff yesterday on stream. It was pretty cool. So we're gonna switch these. We're gonna put the puffer on the top. Oops. Little echo today from the microphone. Hang on. I have my compressor on. Well, if anybody knows compressor settings to help with that, I mean, I can just turn. I don't have my setup that I had in Florida. Like, it's a lower quality mic. It's like a decent mic, but I have a $200 audio setup here, and I have a $1,000 audio setup there. So like, there's going to be a difference. I'm also in like an untreated room, right? I'm just in a bedroom with a desk. So I'm in Florida. How hot outside? Brutal, unbearable. I'm not going to be here for very long. This is my residence, so I'm just getting doctor's appointments and stuff out of the way, and then going to Palo Alto for a bit. Okay. Download PNG. This is fine. This is fine. This. Can I preview this on mobile as well? Let me see if I can preview this on my phone. If it like shows me. It doesn't even show me articles on my phone. Lists, chat. Yeah, that's jank. Well, this one I think is going to be fine on mobile. Oh, you know what? Actually, this is off center. It's like very important to center them because otherwise they get cropped on mobile, and a heck of a lot of people see it on mobile. I'm going to change the title to do this. And do this. And square it up best I can. This. Yeah, that's better. Okay. Enough time spent on prettying this thing up. I wanted this to be done in like a few minutes, and I ended up spending more than that on it, but it's a good thumbnail. And that's a good thumbnail, right? Publish. Publish. Okay, they're live. Look at that. There you all go. So that is 25 pages of educational material. About a third of it is general ML and programming. The fundamentals are very important in this space, and I don't mean like fundamentals as in read Sutton and Bardo and learn a bunch of formalism. Like just knowing basic programming very, very well, and then knowing basic deep learning very, very well are important in RL. All right, that's like the most important thing. And there's no real excuse because there's not like a mathematical barrier to entry here. All right, it's not like you need a decade of math to understand this stuff. It's just nobody does it properly. So that's why I made that. I made that guide because of that, and also because people have requested it. And then the main meat of it, of course, there's the RL guide. I'm gonna go grab myself a cup of coffee, and then we are going to do some work on drones. I shall be right back. Don't let me forget to unmute my mic. Sticking around for drone work? Yeah, that is the main thing of today, after all. It's already at 33. This has been like a couple minutes. That's cool. Hopefully this does pretty well. Like, if this circulates, it'll help a lot of people get into this space. Okay, so time to start on drone things, yeah? I don't know if it's this terminal that causes this, by the way, but this machine does, for some reason, occasionally just hard crash on me. So if that happens and the stream cuts out, you'll know what's happened, and I will be back in a second. We're making do with the scuff stream setup, because I'm on a laptop, and apparently there are no good laptops you can buy these days that actually work, especially on Linux. Okay, so I did run a sweep overnight. I don't think it did anything. But let's just check on our sweep. Linux distro, it's Ubuntu. It's just straight up Ubuntu. I could technically reinstall it because I did mess around with i3 for a little bit, so I could have broken something, but realistically, like, it's almost completely just vanilla Ubuntu. It shouldn't be breaking. It's a brand new Razer 16. I really like the build on this laptop as well. It's just the trackpads on the Razer 16s are all messed up. Like, they all do weird stuff occasionally, and I don't know. I've had a few other problems, some of which are hardware, some of which are software. There are just no good laptops, literally. Like, if you actually want a good, like, metal built laptop with a discrete GPU that's good, like, there just aren't any. Doesn't exist. Okay, so here is the drone hyperparameter sweep. According to this, it doesn't work at all, which is interesting to say the least, because we have it training with our current set of hypers. Something is weird there. We'll have to look at this. Disappointing. I did also leave this going yesterday just to see. So I'm just curious. Wait, one? Is this 100 bill? Yeah, this is 100 bill. Oh yeah, 725 and 100 bill is really good. Okay, this could very easily be a soda experiment. What was our previous best? I mean, it's not by a huge margin though, right? It's like pretty close for being a much larger policy. We'll let it run. Learn the environments. Welcome. I must have done something wrong in the setup of that sweep because, as you can see, it at least learns decently well pretty instantly here. So that's the super, like, these are tiny drones, and then sometimes it'll spawn bigger drones. And the idea here is it has to learn to control a whole bunch of different types of drones. So this is a big slow drone. What is the ideal way for me to compile within? Oh, that's your library? In your mind, what is the ideal way for me to compile incurses in Pufferlib? So do you mean as part of the PR or for the pure C? So with the pure C, we could very easily make it so that the build ocean sh, like that script should just be able to take extra compile args, and then that'll work for you. For setup.py, each individual environment is a module. They're all just done in a loop right now, but it shouldn't be that hard to, like, you know, just add extra args. Like if name equals this, add args that. And you're perfectly fine to do that. As long as you don't link that to literally every environment. If you just link it to your own, you're good. Do you program in Vim? Yeah, it's like NeoVim with 2 plugins or whatever. You can see the setup I have. Okay. Okay, so let me sort of walk you guys through what I'm thinking about right now for the drone sim. We currently have 2 different drone simulators. We have the racing one that I just showed you, but we also have this swarm, drone swarm sim. Didn't PR way to link curses? Yeah, you should do that ideally. So obviously these guys aren't trained to do anything, but the demo that I did for this the other day was we literally hit 10K this morning into 10.1. Holy. Let me find the demo I did for the drone swarm. Okay, right like this. Right. So I think the thing that would like be really impressive and really, really generally useful, right, is if we could just get a drone policy that does everything. Can we get a drone policy that can make flag constellations, that can beat human pros at racing, that can, like, follow targets, just like have a policy that does everything? One big environment, massively multitask, different drone form factors as well. Just make that work somehow. Yeah. Holy retweets, Batman. I have question. What is question, Majid? I'll answer a few while I'm thinking about how I want to make all the drone stuff work with like one policy. Is there sufficient overlap in both problem domains for that? Yeah, there is. It's just a matter of figuring out how we formulate the task and data. How many RAM sticks do you have for 128? I have no idea. It's a tiny box, so you can go look up the tiny box V1 and see if they have specs. Oh, actually, no, that's the 6 GPU machine. Hang on, I do know for the 4 GPU machine. It's just the 4 the 4 GPU. God, I'm all over the place today. The 1 GPU machines are they're just max spec to main gear boxes. So you can just basically just go over to main gear, max everything, go AMD build, and that's pretty much what we have. What if number of drones is more than grid size? And let's say on real life, few drones battery will die. And then you do replace with newly charged. Well, what's the application? Depending on the application, you kind of don't care if a few of them die, or you expect them to. I could very easily make it redundant if I needed to, though, right? Like, I could pretty easily make it redundant. One blue item disappeared. Yeah, so there are like many ways I have of making it redundant. It just depends on how much I want to go problem specific versus general. So here's what I'm trying to figure out at the moment, right? Like most of the goals that I have are some version of go to position while avoiding collisions. The ring target is slightly different because you have to go in from a certain direction. it's kind of tough to do like one giant sim. The thing is, you can really, when you have like different tasks of the form go to position for different patterns, it's quite easy. We have gotten it to work before where it's truly multitask, so you just have the same policy doing different stuff. Explain a basic observation space like breakout. Yeah, that's just where's your paddle, where are all the bricks, where's the ball. Maybe ball velocity as well. It's just all the data. I think at the very least we can combine the two sims that I showed you, right? Like the swarm sim and the racing sim. We just give you like an n ring buffer maybe, and like a load task. Hey, how's it going? I'm gonna say how's it going, Thoda, so I don't butcher your first name. You know, one thing that would actually be really cool, we could make a train env or a test env where we literally load like all of the different drones into the same environment, right? I'd like to train in that setting actually. I don't know how well that would do though, just because of I really need to make better collision checks at some point, you know? Like our collision check logic is not great at the moment, just generally. But if I scrap that for now, and at least I just try to merge these two into one big environment, I think we can do that. And I can just give it like tasks, different tasks. Okay, let's get started on that. How's the article doing? The article is doing very well. how long ago did I post this thing that it's already at 90? It's crazy. Well, hopefully that's a fun time. Oops, let me send one quick message, and I think I know how to do this. What's your Twitch? Same as my X, JSuarez5341. What is protein? Protein is our hyperparameter sweep algorithm. There's an article covering that on my X as well. One generic question, is reinforcement learning like on its own or when data not available? Teaching a robot to walk or solve a maze. I don't quite understand the question. Reinforcement learning is about learning from interaction. So your source of data is the thing that you're interacting with. Usually it's a simulation, sometimes it's the real world directly. We like simulations because they give us unlimited data. Is there a value in injecting real world environment data into Sims? Yes, we do that. In Puffer Lab, are Sims closer to one ideal condition, making it easier? No, actually the opposite. So like this drone sim right here. Here, let me show you this. So originally it was just one drone, which is the real world, it is one drone, right? But this is actually randomizing every single physical property of the drone, every single episode. So this here, this is like a medium-sized drone. You can see it's like a quadcopter thing. And then once it solves this, you're going to see it's going to be a different drone. So this one is like a little bit bigger than the last one, and it seems like it handles a bit better. Because we randomize the size, we randomize the weight, we randomize inertia. So you can see this is like a tiny little zippy drone that handles really well and it's really small and agile. The same policy is controlling all of these. Now it's a really heavy drone. Sam and I are happy to join voice. Oh, perfect, because I was about to do some stuff. Let me just open my CVS grade headphones, because I forgot to bring some with me. So I got these specifically so we could chat. Let's see if these work. Oh, where's this plug in? Plug it here, maybe. Test, yes. Discord. Hopefully this is not super loud, we will see.
Yeah, probably a good
Hello?
idea. Hello?
No, this doesn't work yet. Hang on. Let me get Discord to actually use my headset.
Okay.
Say something? Yeah, now it works. Cool. Now that works. Yeah, I've been punting on collisions. Wait, we could hear before. Now we can't hear. Did I break the stream? Wait. Oh no, I think I broke your audio. I can hear you fine. I broke your side of the audio. Okay, now try this. I think I fixed it. Say something, guys.
Testing, testing.
Okay, now you're blowing their ears out. Let me fix your. Let me just crank you guys down. All right, that should be better. All right, you guys let me know if I have it audio bounce terribly. I'm doing the best I can here. I'm streaming from my laptop with a dock plug in with 1, 2, 3, 4, 5, 6 USB devices. Like it's a whole ordeal,
Right.
all right?
It's a great setup.
Yeah, it's jank. Oh, and Yaxine's coming as well. I wanted you guys to chat because I think you're both messing with similar things.
Yeah.
And I think the
what I
beta
was gonna say,
OB stuff is important.
yeah. What I was saying about the collision stuff is, it was quite a while ago now. It was before drone was written in Pufferlib. This was back in the gym days. But I spent quite a long time figuring out the maths for proper collisions with like. It doesn't require everything to be spheres. You can have planes and kind of triangular stuff as well.
So that's helpful. The thing I was talking about is even simpler. It's just the fact that collision checking is quadratic at the moment.
Oh, all right, okay.
Like,
Right.
ideally, what I would do is I would make some sort of, even just like a basic opt tree would do it. I just don't want to actually have to do that because it's a total pain. But I will do that at some point. It doesn't really matter.
I can't remember if
because like quadratic is fine up until like 256, 512 agents. You don't even notice. So, anyways,
Right.
let me tell you guys a little bit about what I've been doing on this and what I'm planning on doing here. So we now have it so that you can randomize the size of the drone, and then there's also an additional randomization constant or factor for physical properties. And what this does, so first you roll the size of the drone between, I believe it's between 5 centimeters and like 0.8 meters or something, or 0.5. It's like between a very small and like a medium-sized drone, right? And then what it does is it attempts to estimate based on that some sort of reasonable weight and reasonable inertia parameters and all that, and it randomizes those a little bit. So the idea is that you get pretty much any sort of realistic or even somewhat unrealistic drone imaginable. So it should be able to learn to fly any type of drone with the same policy.
Right. Okay.
So
where did you get those? I saw there were some sort of heuristics about choosing the sizes and things. Where did you get those from? Are they just kind of
freaking Grok?
Yeah, fair enough.
Yeah, so some of them are kind of obvious, right? Like mass should roughly scale with size cubed, no?
Yeah.
Right, because it's if mass is distributed evenly, kind of guess that one. And then like some of the other ones make sense, and some of the other ones are more heuristic.
Hello?
So I wanted you guys to take a look at those and see if they're reasonable, because what we would like to see in the sim is we would like to see the drones handling more or less the way that you would expect. I haven't really seen a ton about the drones, like actually flying them, we should probably all do that at some point. But you'd expect that the smaller ones are going to be zippier and have really tight turning radiuses, right? And then the bigger ones are going to have a lot more weight and inertia to them. So we'd like to see that happen in the sim, right? That's the goal. And then you can fly any drone with one policy. And then the next thing I'm doing is I'm going to actually make it so the same policy can do a ton of different tasks. So like not only will you have a policy that can be a ridiculously good drone racer, but at the same time, like the same policy should be able to go make the flag or like orbit in a sphere or do any of the other tasks, because they're all some form of go to point. With the ring, it's like go to point from the right side, but no big deal, same thing. So we should basically be able to train it on a huge number of randomized tasks and randomized drones. And then with that much diversity in the policy, there's probably going to be some fiddling around to get it to work on the real hardware, but that's it. Hey, Actian's here. Welcome.
Hello.
Hello.
I appreciate all the work that you guys have done, especially like just having the actual source and being able to run it and look at it and to change it, see things break, change it, see things improve has been super like useful for my learning. So I really, really appreciate it.
Hey man, I am trying. It's
That's cool.
if you saw the process of getting it to where it is now over the last year, like first it was Python with this emulation wrapper over existing gem, and then we went to Cython, and then we had like prototype binding, C API stuff, and then we got something that had like horrible memory leaks. And then we got something that's pretty dang good now. I still hate the fact that we have as many files as we have for binding layers and this and that, but Python makes it really obnoxious to like get it any
Yeah.
simpler than this.
Actually,
the binding.c is like 100 times better than before. I hated
Yeah.
the Cython. It was just rubbish.
I like pulled all the code and I now have one train.py, one eval.py, one env.py, and one c binding.c file just by like working off of it. And then I'm importing your vectorization stuff, which I still don't understand what that does, but all
That's
the
pretty
other
much
stuff is
what we have,
imported.
isn't it? Like we have like Pufferlib, if you think about it, there's one trainer file. There
Yep.
is the vectorization file. There is for each environment, and this is a slightly annoying bit, right? Each environment has a Python file, it has a binding file, it has a .h file where all the code is, and then the .c file is just so that you can play with it in pure C, right? So you don't have to
Yes.
dev with compile to Python every time.
Yes. That's pretty much like close to my setup too. So it's I mean for what it's pretty much copied to your setup, right? So it's the same code as well. So I mean,
All right, yeah,
I think the actual sauce is like the trainer. There's like that CUDA thing that you've done, and then also the vectorization file, which I think just compiles it with certain flags or something. I'm not sure what that does, to be honest.
What, the vectorization file?
Yeah, like the VCN.
Vecenv?
I can kind of
Yeah.
guess that it's
Oh, so what that is sort of like a Python implementation of envpool, if you've seen
okay.
that
Oh, okay,
paper.
okay. Yeah.
So it's pure Python, but everything is done through shared memory. So the secret sauce of Pufferlib being fast with C is that when you are writing your environment, the observations are going directly into shared memory that's available immediately on the main thread with no redundant copy operations.
Okay, yeah. I actually have done something similar with doing Conway's Game of Life with a Go server that was pushing packets to a website which would render it. And I had this double buffering thing happening with CUDA, and it would just you kind of have to control the memory to keep things really, really quick.
Yeah. So it is most of our stuff is double buffered. It supports more than that. You can triple or quad buffer, for instance. In Puffer
Okay.
2.0, we actually had it so you could do full async. So it's not even buffered. It just takes data as it's ready. We got rid of that for now in 3.0 because it breaks the way that our new trainer collects segments.
Okay.
The other secret sauce, did you read the Puffing Up PPO article? It's super short.
I will read it soon. I've been mostly just heads down
Yeah, gotcha.
running your training loop over and over again, changing the environment,
Yeah.
running a training loop.
There are a couple things we're doing that are non-standard that will probably benefit you to understand. So we're not quite doing PPO. It is built on PPO, but we've done our own research and advancements. It's a generational leap over PPO. Everybody
Yes.
claims that, and they are all wrong. Ours actually does work. And
Yes.
the reason that we know
I mean,
that is because it's 40,000 experiments.
Yes, I've been like running it and using
Yeah.
it over and over again, and it's actually kind of remarkable how easily it works.
Yeah.
It's pretty astounding, to be honest.
So that article has all of the advancements that made that possible. It's a pretty simple set of modifications to PPO, but like the stuff that actually mattered. Honestly, muon was a big part of it, and then I think trajectory segment filtering was the other big part, and then the other stuff was more minor.
Okay.
When are we
I
getting
will
multi-agent drone flag env? It's already live, Imagine. You've got all your fans like going nuts in the chat that you're here. Welcome,
Yeah, I
Lobo. We
mean-
haven't ever chatted.
Yeah, it's yeah, I yeah, I hope I'm helping.
Oh, you
part
are
of my
absolutely,
intention.
man. Thank you for all
I'm
the
very intentional.
the
Yeah, I
views.
mean, it's like when I see something that's like sick for me, like I'm very intentional about sharing it as much as I can. I have a lot of reach, and
Yeah, you
I
can see
do it,
mine is
like,
much smaller and more concentrated. Like I very rarely post things outside of direct RL. So it's like a really just like core technical audience.
A technical audience, a technical follower is worth 1,000 non-technical followers, and in fact, you saturate your bubble astoundingly fast. And I think part of the reason I've never planned to actually have this much reach, and I think the reason I have this much reach is because I change interests every 3 months. I get like hyper obsessed about something. Right now, it's like reinforcement learning and like robot
Yeah.
control. So I'm going to gain some followers who are like, oh, this person's posting about robot control, and then like next week it'll be woodworking, and then I'll gain some followers who are talking about woodworking. But if you keep on posting cool stuff, like once Finn and Sam actually do the SimCity Real, which is going to be very interesting and very fun.
I think it'll
And you
work.
guys have an actual. I mean, you're literally going to have an American flag flying over your property, right? Like, this is actually going to happen. Like, I guarantee you
Yeah.
that you guys are going to be successful in the next 4 months.
Well,
I will be seeing an
wrong-
American flag flying.
Wrong flag, but wrong flag. but
We'll
sure.
get you guys over to here. You're not enough freedom. All right. We'll get them some good barbecue. All right. I know you guys, the food there. You have like your beans and toast. I don't know what that is. You'll get you some barbecue. You'll like it.
So you guys have hardware now, like as I understand it, like that you're trying to push the drone policy onto, right?
Yeah, I sent them a basic
Yeah.
drone to like start fiddling with. I'm traveling for a bit, so it's not as easy. But once I get back to the farm, I'll be there. Probably order more drones, see if we can get multi-agent
Sweet.
stuff. I mean, it's just, we do stuff in a number of different industries. I don't really change interests every 3 months. It's kind of just all RL. But we are floating around in applications, right? The goal is to do general purpose reinforcement learning for pretty much everything but LLMs. So
Yes.
drones are a big
No,
application
why is-
of that.
Why is no one doing this? I don't understand why no one's
Because
doing this.
LLMs are
Like,
the shiny thing at the moment.
yeah,
and, like,
that's true, right?
And the thing is,
Um,
so
And
it's
we don't have enough graphics cards.
you don't even
You don't even need
a
that much.
ton in
Like,
RL.
I have a 4090 sitting on my floor. Like, I have a 4090 just sitting on the floor, not even plugged in, because I don't have enough power going to my house. I have two 4090s. I just have two kernels running. One is attached to CUDA 0, one is attached to CUDA 1, and I have a script that throws. So I'm running two trainers, like two training at the same time, often with Pufferlib, and it comes back in 1 minute. It's fine.
We have we've got like 20 for us at the moment. 20
Okay.
4090s total. We got two tiny boxes in there. Those are the bigger machines, 6 GPUs
Nice.
each. So the biggest run we've done is it's the petabyte article. Petabyte article. And that one we did 640 billion observations worth of NeuralMMO 3 with like a 3
You guys
million
are-
parameter policy.
You guys are the only ones doing this, right? Like,
Yes.
I've never seen anyone try actual scale. Like, this is
Yes,
that's
this is
crazy.
the only place.
This is that's like I can't believe no one's done it. It makes me very sad.
So
It's like
it's very difficult for me to express because like you come into this and you see, oh look how simple it is. It's like a few thousand lines of code. It's
Yeah, there's a
really
lot of
difficult
work.
for me to
Yeah.
express like the amount to which you had to flip the field on its head to make this work.
yeah.
Like Pufferlib got rejected. I've been developing this thing basically since towards the end of my PhD. All the pre-1.0 versions got rejected. 1.0 got rejected from conferences, and then 2.0 got rejected once or twice as well. And finally, it's just getting published at RLC. I'm no longer
That's-
writing
yeah.
papers because I'm sick of dealing with this crap. It's the publishing stuff is horrible. Like scientists are just allergic to engineering. Even when
Yes.
it's like they are directly the thing that they care about doing just requires them to write some basic C. They just won't do it.
I was talking to a roboticist from ETH Surge, and he's
Yeah.
really great. He's really plugged in. And I was surprised because you explained to me like how ML researchers work in those fields. And I was like, oh, you guys like actually don't do hardware. It's like, oh yeah, that's the hardware guys. Like those are the simulation guys.
Mhm.
But in my mind, the frontier is pushed by doing the vertical integration of the whole thing. Like you have the same people doing the simulation who are building the hardware, and you have those very same people also training the neural networks and actually engineering like every single thing, actually building the machines that these
Yeah.
things are training on. That's how you get that next like frontier. And that's the same thing that happened with ImageNet in like whatever it was, 2011 or 2013 or 2012. Like,
It's
that's what
just
happened with.
when you want this to work. I've worked with people in like a number of different sub areas trying to do RL, and it's everybody just underestimates the price of complexity. And now that's
Yes.
true in software generally, but it's especially true in reinforcement learning because
Yes.
when stuff just breaks, you don't get error message. You just get the thing doesn't
Yes.
train, right?
Yes.
So like in fact, I'm even guilty of this. So when I first got in, like when I was newish to RL, like even a couple years in, and CleanRL was becoming a thing, I thought, okay, this is dumb. Why don't you just have like this 300-line script? And that was, I've never been more wrong about something technically. CleanRL is a godsend, and like if you actually want to see the person who made all this stuff possible, it's Costa. He's like the only person in the
Yeah.
field who I have literally nothing bad whatsoever to say about. He's just pioneered all this stuff. And his insight was like, what if we just do this in the simplest way possible and make it super hackable? And what
Yeah.
I've done with Puffer is try to keep it as simple as possible while also making it fast.
I mean,
Yeah.
it's like I can testify that it is a very hackable. I mean, I literally just went to the Python package, pip package, and I just read the code and I copied things over, and it like literally just worked. I mean,
It's
that's
gonna get
that's
even
the
better.
core feature. I mean, that's exactly right. Like you're kind of like iterating on this like
Mhm.
over and over again, doing newer and newer versions and pushing things simpler and simpler. And like that's like the main feature of like any code base. Like I judge a code base. For me, a code base's value is determined by how easy is the code base to change to my requirements, to the
Have you
thing that I
played with
want
like
to do.
RLib or SB3?
No, this is the first time I've ever trained RL models. I've
So
actually, so 2 weeks
yeah.
ago I started with Mujoko, and I got a hot dog to balance, and that was kind of like I
Yeah.
wish I could go to like I hate Jax. I don't
Yeah.
like XLA. Like I don't know
I
what the
don't
fuck
either.
it's doing. What is it even doing?
Yeah, I don't
Like it's
either.
so, but with this, it's like I can understand like PyTorch functional is my shit. PyTorch, like I can just read it. I can understand what it's actually doing. The C is like I can read it. I can understand what it's doing. I can write any renderer I want. I
Yep.
can plug it into Raylib. I can plug it into like terminal output. Like it doesn't fucking matter.
That is the
And
goal.
that's the most important thing is I can understand it. I know what's actually happening. And when I understand things at their fundamental level, then I can understand what's possible to do. And I mean, I'm getting really excited because I mean, the thing I'm trying to do is kind of I'm trying to meme. So I have a hard hat which I
Of course
bought
you are.
because I was out with my kid. It was right next to the Chinese place I was ordering food from, and I want to make it fly. And I think like I can make it fly. Doesn't seem that like complicated to simulate. I mean, if I can run your code and hack on your code, that's like making a drone fly. And I also added. I know you guys are working on domain randomization, and I did that yesterday. I added mass randomization, and
Oh, take a look
it
at the
worked.
function we added for that. So it can now
Okay.
fly like all different sizes of drones with like
Okay.
kind of reasonable-ish estimates and randomized masses, lengths, inertia. There's a whole bunch of stuff, and it still flies like all sorts of different drones.
It's
Same
kind of
cost.
remarkable. Like I trained them. I didn't train a new neural network,
Still works
and it was
decent.
still able to fly ever. Yeah, it's
Yeah.
kind of neural networks are actually kind of amazing. Neural networks are actually remarkable, and so
It's
I
tiny,
guess
so
I'll give you some. It's so small.
yeah, it's
It'll run on a
130K
potato.
frames.
Yeah, dude, it'll run on a potato. Like this is I don't understand anyway. Anyways, I'm very excited. So I'll give you guys some advice about this is how I'm going to go about getting my hard hat to fly.
Mhm.
I'm going to 3D print a vertical thing, which is basically like a modulation of like some aluminum extrusion, right? And I'm going to attach that to a brushless motor, so it can only go up and down. So I'm going to put some WD-40 on it. I'm going to have a Newton meter at the bottom of it, and I'm going to make the brushless motor. I'm just going to send ESC commands to it to set at a certain speed, and I'm going to measure the rate at which the speed can change, at which the force can change, and I'm going to try to model it the best I can in an environment. And then I'm going to model the environment and then have it like basically randomized. And then I'm going to try to do sim to real to that. Yeah, exactly. And then I'm trying to move it over, and basically the goal will be try to float halfway through the thing. And I think it'll work. And there's the way I'm going to measure the length that it's going to be. I haven't figured out yet, but it seems like it should be that not too difficult to do. I could probably even do it just computer vision. But once I have it working on one axis, then I'm going to move over to actually having something fly. I feel like that's going to be a little bit easier, and it's also going to like shorten the time where I actually have sim. Like my goal right now is like I need sim to real today. If I want my hard hat to fly by let's say Tuesday, I need sim to real to work today, and I don't think I can get my hard hat to fly today. I probably can get this 3D printed thing, and I can get a brushless motor, and I can have it like have it create some thrust. Like I can try that, right? Like, and the
Yeah.
thing I'm trying to like do is like reduce the amount of requirements such that I get to a point. I think like doing I mean I could budget to get a drone as well, and
Sim to real, I think we can get that to work for you. It's like I pretty much just have to show you the way that we actually domain randomize stuff. It's a lot harder with actual super high dimensional robotics because you can't randomize all the relevant stuff. But I think it
Yes.
shouldn't be that hard with something like this.
I mean, I have it working with mass, and it works pretty well. Like the only it fails on 0. So I have the mass randomizing from
Mhm.
0.1 kilograms to 3.5. It works above 0.5 to 3.5 kilograms. I actually just like went out to Costco and I just
Yeah.
trained a model for as long as it like I trained it for like 500 million instead of one. I
Mhm.
can't even remember. I just like added a couple bunch of zeros to it. So I'm gonna try that and see if that works. But I mean, I don't know. And like I'm excited too because like just the 30-second training loop, dude, just means that you can actually hyperparameter sweep.
Have you tried
And
protein
like,
yet?
no, I have not tried. I'm really
You
excited
have
to
to
try
get
it.
it set up properly. There's one obnoxious quirk with it that I didn't have time to fix before 3.0. That
Okay.
it doesn't like always work the way it's supposed to work perfectly, but when it does, like this is how we got breakout speed running. Solve breakout under 20 seconds, solve Pong in 3 seconds. It's our
Wow.
own hyperparameter tuning algorithm. Like you
I-
can read the
so
article on it. I actually had to do some math for once for that.
okay, I'll read it, and I think that like
They're all pretty short and easy to read.
the way I have things pulled out basically means that I'll be able to like rip out what you guys are doing and I actually just like run it on my own thing.
Yeah.
Because I have like really strange infrastructure. Like again, like I have like a train.sh, which sends my code over to my server, rebuilds the Python bindings, trains it, and then has it automatically like, open a PyPlot on my laptop every like X amount of epochs, and then
You can do that.
I feel like yeah,
I
I
would
mean it's
suggest
like
if you want to replicate existing stuff, I'd suggest at least not dropping the core features that we have because like it's a small set and they're really useful. Like the local dashboard, for instance, that we have is really useful for fixing performance bugs. The
the
Neptune or
that that
Wanda
I kept.
integrations,
That
like
that I kept, like the
yeah, that's
the
good.
dashboard I kept. It's like very, very useful to just see it like actually ripping, and like when I
Yeah.
make a clear mistake, it's like the numbers look fucked, and yeah. Or sorry for cursing, but yeah.
So you don't super need Neptune over like just a plot thing for individual runs. When it's really
Yeah.
helpful is when you have sweeps and you need like scatters for every hyperparam because you're like doing sensitivity analysis and stuff.
Okay.
Like
Yeah, that's
that's what that's for. Like
Okay.
there's more advanced analysis basically that stuff supports.
What I'm gonna
I don't like
do
it either.
is
I don't like that they all suck, but like you need something that does it.
what I'm doing is I'm dumping all the logs to
Mhm.
JSON line file, and then I just like open that up with like a notebook, and I just like hack with the plots that I need to. So I feel like, I mean, I
Yeah,
can
the
generate
plots
code
that
very
you'd
quickly.
want to generate, it's going to be like last data point scatters over a bunch of different hypers. And it's going to be like
Okay, got
scatter
it.
of hyperparam versus 4 or
Yeah.
whatever.
Yeah. Those like fancy plots where it like changes colors and stuff.
Neptune doesn't even have that properly. I asked for
Yeah.
that. But yeah, it's ideally you do some nice stuff with that.
Yes.
I haven't really bothered with it because it's like having the web
Yeah.
UI is just, it's
Yes.
nice because I can link it to people easily and such.
Yes.
And like I can log from my server and not have to sync stuff. But all those apps suck. They're all super slow and bloated. So man.
Yes. They're very slow and bloated. You know what? It's nice, dude. Having one file that like has everything. Like let me
Yeah, I
let me
know.
let me read what my file has.
I could make a
So
one file like version of that stuff to be honest. You could very easily hack like a minimal Wandby out of Raylib plots.
I've already like yeah. I mean I've already yeah. It's I mean like my file is puffer RL class defined print
Mhm.
wow CUDA equals 0, and then that's a bunch of copied code. Compute puff advantage, abbreviate duration, utilization, file logger, which is my own logger, train, and then drone policy, and then drone env, and that's it. And then the train function, and then the actual config is like just defined in a dictionary, and that's 1,000 lines. And I just run that Python file, and it rips, and then I change something, and then I run the Python. It's so fun, man. I've been having so much
Yeah.
fun.
We
I've
have a
never
whole
had so
bunch
much
of
fun in my
people that
life.
are here like chatting and like asking questions.
Let's
Uh,
go.
really just super quick. Jax is functional, PyTorch is object oriented. Yeah, they both suck. The thing is that Jax is like compile default, and it really gets in your way a lot more than PyTorch, annoyingly. I don't love either of them, but I do take PyTorch over Jax at the time being. And our stuff is this fast in PyTorch eager mode. Search can reduce complexity, depends on the environment, unclear. That's in the guide that I just posted as one of the topics I want to look into. One file for M sweep hyper, yeah, exactly. I miss anything else? Nah, a bunch of meme posts other than that.
Yeah. Yeah. I'm very excited.
Yeah, it's
Are you
super
excited,
fun.
Joseph? Are you excited?
Yeah, I think I'd like to be able to get back to like the core tech, because there is a Puffer 4 plan, right? Like the algorithms can get way better than this even, and I know exactly how to do it. But I'm
Dude.
kind of at this point, I'm doing drone stuff, I'm doing like various applications, and I'm kind of building the company side at the moment. Goal is to make this thing successful enough that I can fund like open source private lab a little bit larger on
gonna-
this.
You're gonna make so much money. Oh my god. You're gonna make so
Hopefully.
much money.
My goal is to be able
I
to fund
don't-
all sorts
I
of
don't-
research.
Right, like if you get, I mean, here's let me give you an example, okay?
Mhm.
If you take my hard hat code and you open a box
Mhm.
and a hard hat flies out and it lands on your head perfectly, do you think you could sell anything to anyone if you can do that? If you can open a box from Costco, one of those plastic injection molded boxes, a lot of them here in Canada are actually made in America, and you open the box and the hard hat flies out and it lands on your head, I will buy anything from you. If you tell me I'll bill $10,000 an hour, I'll be like, I'll give you 20. If you can make a hard, because no one can do that. Like and
We
here's
have
another
all
thing, is like
sorts
from
of cool
first principles.
demos like that. Is that like the thing is, I guess they're not as like visually obvious as that, and that's what we're working on. We have all sorts of
Yes.
demos that if you have any idea about RL are like nuts.
Yes.
It's just like flying hard hat isn't a product. Like that will get you investors. That doesn't immediately create you a big revenue stream though.
But how hard would it be for you to turn that into a product, right? Like effectively for you to like create an actual physical product, you would have to raise the capital to do it. But what you can do is you can go to a customer who already has a bunch of capital and you're like, hey, I'll create this product for you that you want to exist. Here's the proof of existence that I can make anything happen. And it'll probably take you a week after to make that product and creating
That's
the production
mostly
line
what
for
we're
those.
doing at the moment.
Yeah.
Yeah, that's
Yeah, that's
mostly
good.
what we're doing now.
That's amazing, man. Like I'm so glad I like discovered you. Like this is
Thanks, yeah.
the amount of work that must have gone into this is
You know, it's
mind-boggling. Like
the thing that I think was the most frustrating with this, it's not the amount of work, because everything is a huge amount of work. It's just like the sheer amount that I had to fight academia on everything for this. Like I could not have made Pufferlib during my PhD, even though I had an advisor who basically let me
Yeah.
do whatever I wanted. It's just like it's so upstream.
Yep.
Basically, reinforcement learning killed itself as a field. Like
Yes.
academics, they killed their own field
Yes.
by essentially just being a bunch of bookworms. Like,
Yep.
they literally like they made slower and slower benchmarks, and then they adopted like slower and slower best practices. Their dev cycles would be like 2 days to 2 weeks to train Pong or whatever. They had no GPUs. The GPUs they did have, they were running at like 1% utilization, and yeah, the field just died because nobody could do any science, and then everybody went over to
I'm-
do LLMs. Like,
I'm crying. I'm actually
Yeah.
crying.
so it,
I'm
like seeing
legitimately
that
crying.
happen was not like I used to know a lot of really smart people in RL, and zero of them still do. I think
Yeah.
one still kind of does RL on LLMs, but like zero of them actually do this stuff anymore. I'm the only one left. I've got like,
Thank you.
yeah, it's tough.
Thank you. No, thank you. Thank you for hanging in there. Like, so I'll
Yeah.
tell you a comment. So I made a post. It's kind of a meme. Like I'm kind of joking, goofing around. I still haven't actually learned RL. It's probably going to take me probably 3 months to really like understand everything. But I said, oh, like I learned reinforcement learning in 2 weeks.
Read the guide.
And someone replied, yeah, like I'm going to read the guide. I might actually learn it in 2 weeks with the guide. But one person responded to me is, oh, really? Prove it to me by getting a paper accepted.
That's
And I
not
replied
it.
to him, oh, I'll prove it to you, but instead of getting a paper accepted, how about I make $1 million with RL? Would you believe me then? And I feel like,
Both
you know,
of them are no.
I mean, I think that I could actually make good money with reinforcement learning. There's a lot of things that, I mean, even just like think about this. Like I don't know if you've played World of Warcraft, but I did when I was younger. And if I could get
MMOs were my PhD, man. I literally did my PhD on MMOs and RL.
so if you made me a World of Warcraft figurine that did the World of Warcraft dances, I would buy it for $500. I would buy it.
We did animation generation, like grounded animation stuff with RL for our client.
Yes.
Yeah.
I mean, the sauce is out there. Like Disney's publishing papers. I've been watching like all the YouTube videos and reading all the papers and stuff. And you could 3D print a World of Warcraft gnome doing the World of Warcraft gnome dance, and you could print a World of Warcraft night elf doing the World of Warcraft night elf dance. And like it
Yeah.
might take like a hardware engineering, like the engineering. I guess all the stuff that the bookworms don't like doing is the actual hard part, and you'll end up learning quite a lot of stuff doing that. And it's totally possible. If you're telling me these Chinese robot dogs can handstand, then
No, they
we
totally
could
can.
totally build.
I'm looking more at like big industry problems in logistics and control. I think
Oh,
longer
wow.
term, I really want to do more material sim stuff because I think like
Okay.
there's a huge opportunity for RL plus fast sim to unlock a ton of stuff over there. But I think
Oh,
that
yeah.
earlier on, it's like logistics and low dim control are like just
Actually,
really good for RL.
Thank you for reminding me. I need to put you in the contact with my friend who's. Have you gone to Palo
No, I'm
Alto
in
yet?
Florida for a little bit. I'm there from like the 16th ish to I'll be at RLC, which is actually in Canada. You guys get another crack at me in
RL
Canada for a bit.
City. Where is that?
What? Alberta,
Where-
University of Alberta.
Or Alberta? Oh yeah, Edmonton. Okay. Cool.
Let me
So
answer
yeah,
a
if
couple
you
of these
end up,
just real quick.
yeah, sorry.
Like, because you got people, so academia, what university? MIT. It wasn't MIT fighting me, it was the field in general, the publishing cycle, review, like all that. Hardest part is slow environments. We have fixed that completely. Very good research to advanced RL. Yeah, we fixed that completely. Our environments are 1,000,000+ steps per second per CPU core. You can train at millions of steps per second on your own machine. Yaxine has no idea how much Joseph yelled at those unusable codes. Yeah, I've ranted a lot. One smack on Pop4Lib. Smack is slow. I'd have to rewrite it from scratch. I could do that. I'm very capable of doing that. I've done similar stuff. It'd have to be through a contract. It would be too much work to just do on its own. Cool. Yeah, so more logistics, more material stuff. I'm very interested in chatting with people.
Yeah,
on
you know
that
he
earlier.
deadlifts 600 pounds.
600 is very different from 400.
Yeah.
My best
I
is
thought it was
410 for 2.
Yeah, that's oh wow.
Yeah,
I need to start working out. I
Your
think I saw
country
in your
nearly
one of
killed
your.
me at NERPS last year, man. I got pneumonia, was in the hospital for 4 days, lost 18 pounds.
Oh.
It's a whole ordeal.
Oh my
So-
goodness.
so,
See,
getting it back.
never go to NeurIPS. Just don't even bother. Just don't even bother.
It's just a mess. But I don't know. I'm getting back in shape. What I did, I'm not there at the moment, but the warehouse streams, I have all the weights behind me, and
Yeah, dude, I
use-
saw you had an American flag, and actually,
Yeah.
like behind me, I have a squat rack myself, and I have a Canadian flag. So
Yeah.
except
I gotta get my
probably-
I got patella tendonitis. I gotta get that fixed so I can squat again.
Okay.
Deadlift is back up to like 350 for some reps cold though. So I don't know. I haven't
Not
tried to
bad.
max it lately, but it's getting close to back.
I'm getting a little older, and my approach to weightlifting is I don't go over what a regular strong dude would do, and I just make sure to do it for higher reps because I'm kind of worried about just like messing my shit up.
Yeah, I honestly it's like repetitive stuff and then just random things have been all my injuries, not even just going heavy. It's annoying.
Okay. Interesting. Yeah. 600 pounds is insane though.
No, 600 is that's very different from 400. That's tough.
I think he's doing a PhD in material science. That's what he's doing in Stanford. So
Yeah, Stanford was my undergrad. I'm like right by that area when I'll be in Palo Alto, so more than happy to chat. I don't know very much at all about that field. I've been kind of studying hard sciences in my my spare time a little bit, trying to think about this stuff. But it's probably going to be the case that if we find like a problem where I just go, oh yeah, that's an easy RL problem, we can just do that. Then I can probably do something early in material science. If not, it's probably going to be the type of thing where it's like, do some logistics or control first, make enough to like fund some really hard sim development, and then do that.
what I've learned is that you can learn once you have the base technical skills,
Mhm.
you can learn anything in like actually 2 weeks. I don't think material science is that hard. Becoming an expert in it
So
is difficult.
the thing is that I would need to. Here's the thing, right? It's not like textbook stuff. It's knowing enough material science to actually figure out if there are sims where you can cut like 1,000x compute corners and do RL, right?
Right. Okay.
That's
Yeah.
the hard part. Like
Yeah.
all the stuff in my guide, for instance, the stuff in my guide is not stuff you will find in textbooks or anywhere,
Yes.
right? Like
Yes.
that's the type of stuff that it takes a long time to learn. And even
Yes.
if I write it there, the thing is like, frankly, you really can't just learn it by reading it because you won't have context for why and the extent to which some of these things are true. right?
Yes,
Like
there's things that people will do that like
yeah,
once they master something. For example, like I spent a whole week just setting up a dev loop where I can run these scripts and actually just have it pop
yes.
every 30 seconds because
Mhm.
I've been doing this for a very long time and I know exactly what is important to like make an astounding amount of progress. Like that is just the most important thing. And like I could tell people this and they just won't even listen to me. Like they won't take me seriously because
Yep.
they'll agree with it, but they won't actually act on it because you'd have to be a little bit insane to do what I'm doing with like setting up this much infrastructure just to get a fast dev loop. But for me, it's like that is the most important thing.
Yeah.
Having a super tight dev loop is the most important thing. Which is like, I mean, like honestly, the the MJX training loop for me was taking like 7 minutes or so, and it was killing me. It was actually killing me. It was
Yeah, so
completely killing me.
PhD is that, except your dev loop is like 3 days. That was
Yes,
the RL PhD. That was the state of RL in academia.
that's awful.
Yeah.
I mean, like at that point, like I would even if I was a bookworm, I'd be like, I've had enough. I'm going to learn
Yeah, but
C.
they can't. It's
I'm
the
going
thing,
to
because
learn.
every time you try, like they actively punish you for it.
That's awful.
Yeah, because it's like, okay, well, if I just here, like one of the first obvious things did was what happens if I just 10x the or like 100x the batch size for Atari, right? It's like, okay, cool. You can actually get Atari to go from 500 steps per second training to like 20,000 steps per second training. That's at least like kind of something horrible by today's standards, but it would have been good by back then. The thing is, then what they'll do is say, oh, you trained it 10 times faster in wall clock, but you used more samples, therefore your work is invalid.
That's
You actually,
makes me
what you
want
have
to
to do is you have to run the entire Atari 57 with multiple seeds each at the slow pace. And like we did this once for one paper, it was over 10,800 hours just to run basic ablations on one set of experiments.
that makes me very sad.
So yeah,
What are you trying to
the
do? Are
field
you trying to like
kamikaze.
yeah, you're like fighting on benchmarks that don't make any sense.
So
The
we
thing
were
that actually
trying
makes sense, the
there.
only
We were
yeah.
trying to like this is actually one of the things that really pissed me off. So I talk about research being wrong all the time. We were trying to see if the tricks that were introduced as general purpose enhancements to RL and Dreamer v3 could be applied to
Yeah.
other stuff. Yeah, the paper's wrong.
My God.
Yeah, just like the whole paper. It's like probably the most cited paper now, or the most best known paper in model-based RL. I don't think that the result is necessarily wrong, but the reasoning behind all the stuff in the paper is completely wrong.
Yeah, there's a lot of bullshit. There's a lot of
Yeah.
bull crap like out there, man. It's kind of surprising to me, especially when I'm like coming as a novice and I see these things that are kind of like obvious. Like the first thing I noticed was like, wait a second, has no one actually tried to scale this stuff? Like that's the first. I mean, you can go back through
But
my
you don't
tweets
see
like maybe
why,
3 weeks
right?
ago.
You don't see the reason why, because you don't like.
Yeah, like I
if
don't.
you've tried RL, you'd understand, or like SB3, you'd understand that
Yeah.
that was the default.
I mean, like that's the thing too. It's like, but I guess like that's the advantage of being a naive amateur at all times is that you don't, you don't have the dogma in your brain that prevents you from asking these sorts of questions. Which is honestly like because I kept on posting about it, like
Yeah.
is how I ended up finding about you, which is okay. Like thank God, like I'm not going crazy. Like a lot of the times it makes me second guess myself because am I just being an amateur? Is there some information that I just don't know that
There
this
kind
obvious
of
thing that
is.
isn't being
The thing is that you don't. The context you're missing is that the questions that we had to answer to get to where this is now.
right?
So I mean, here
Yeah.
I interned at OpenAI in like 2018 when they were doing
Okay.
Dota, and like they had infrastructure to scale, but it was really heavy. Like it was like
Yep.
this really heavy TensorFlow thing with a bunch of
Yep.
Redis and a bunch of other crap. It's not something that looks at all like this, and we're on the same order of magnitude for training, just training data processed as OpenAI 5 now. It's kind of ridiculous, and that's
That's
like
crazy,
1,000
dude.
GPU run. Now
With
that's obviously a hard
14090.
problem. No,
With
not one. It's like
14090.
that's on 6. We can do it on 6. It's a
Okay.
huge amount of data. Like, but the thing is, nothing's ever really been done this scale outside of the big labs at all, and we
Yeah.
can just do it, and we can do it on things that we can't even. Like, we're not even restricted to things that are easy to program on GPU sim, right? We can just write arbitrary C.
Yeah. This is amazing. I mean, that's like I can actually just like edit it
Yeah.
and it just works.
So to finish that answer though, the context you're missing, right? So when I was there, have you seen any of my work on neural MMO?
I've just found out about your stuff. So I've
So
had
okay.
0 minutes for free
So
time.
basically, I did my PhD and like 2 years before that on like what if RL on MMOs, right? And the idea is like MMOs are these incredibly rich, diverse environments that should give you some sort of general interesting intelligence. but like the entire infrastructure stack of reinforcement learning was basically set up for Atari. And
Yes.
like when you try to do multi-agent, everything breaks. When you try to do interesting action spaces to model like realistic stuff in an environment, everything breaks. When you try to do like the observations you need to have an environment work that way, everything breaks. And
Yes.
my PhD was essentially spent on like looking at different ways to get reinforcement learning to actually work on harder problems. And I came up with like stuff in Python that made RL 10x faster by those standards in pure Python. I came up with all sorts of techniques for observations and action spaces. And like I saw a lot of things that do and don't work. And that kind of laid the groundwork for how I built Puffer. And if
Right.
you look at the Sims now, like nobody really builds Sims in this way because you wouldn't know to do it if you don't have that context, if that makes
Yes.
sense. Like Neural
Yes.
MMO 3, if you look at the policy, it's on puffer.ai. There's a policy in your browser that has been trained on
Dude.
a petabyte of data. And
That's
that
how
policy can do basic trading on a market, like they can trade with each other. It can forage for resources. It knows how to use tools. It knows how to like equip items and stuff. It doesn't have like the high level intelligence that you'd want quite yet, but like this is a 3 million parameter model that does all this. And yeah,
It runs in your browser. Like there's
Yeah.
these things that like I just noticed about Puffer that stood out to me. It's like, oh, he's using like WebAssembly and like just rendering things to a canvas. Like that
Yeah.
this guy knows how computers work. Like people don't know that you can like use a WebGL shader to do a forward pass. Like people just don't know this. Like you can do there's like quite a lot of things like that's what I do on Dingboard. I have an embedding get processed by my backend. It
Mhm.
pushes the embedding to the front end, which has like is the embedding of the image. And then I have a smaller neural network on the browser, which then does the final leg of segmentation prediction
We're
based on
not
your
even
mouse
doing
input.
that. If you see
Well,
puffernet.h, it's like the dumbest, least optimized pure C implementation that matches.
Yeah, it's literally
PyTorch
just
layers.
LTSM network, STSM, whatever.
LSTM, yeah.
Yeah, my a little dyslexic, but yeah, like I just saw, I was like, oh, that's amazing, and it
see.
literally builds and it runs on anything because
Yep.
it's Raylib, which is amazing. I mean, yeah, dude, this is, I mean, I'm really impressed. Like, the thing is, I've done this, I've been doing this generally just software development for money, like long enough that I understand how much work goes into having this little code, like
Yeah.
this little stuff. Like I can act like the fact I was able to read it in like a couple of days and understand most of it, like that's kind of, and it works this well. That's pretty incredible. Like that's
Yeah, this is just like we just finished our 3.0 that makes everything like algorithmically this good. So 2.0 was
Yeah.
like still a million steps per second, but it was just PPO but fast. We didn't have our own algorithmic research in there. 4.0 will have a lot more on that, I'm sure. And it's just there's been a lot of stuff with it. Actually, there's several places we can make this faster. Like I'm pretty sure we can make the small nets run at 20-30 million a second if we're smart. So
Yeah.
we can literally have like instant dev loops. That's going to take more work though.
that's I don't think people understand that, dude. Like the thing is, like you're saying that to me, and I can see it, and I don't
Well, you
think
just
people actually
compute
understand.
flops, right? It's
Yeah.
literally just like what's. I mean, you don't even have to compute flops. Literally, just run a perf test on 1,000 hidden dim LSTM. Okay, it's quadratic with hidden size, so it should be able to be like 64x faster or whatever. Is it 64x for 128? I believe so. All right, it's not 64x faster. It's like 3x faster. Well, then there's like a gap of 20x. Duh.
Yep.
Right.
Yep.
That's it.
How fun. One of the things I was thinking about, like simplifying stuff on my end, if I had the time to do this, I would probably have ended up doing this, is doing the PyTorch from C, just like calling PyTorch bindings from C, and just having everything in C. So the environment and the policy and everything could be just defined in C.
Yeah, if I do that, nobody else will use my stuff.
Yeah,
Is the thing.
that's a problem, eh?
And
Yeah.
it's not. I wish if PyTorch actually had C, I would consider it. They have kind of shitty C++. Like,
Uh-oh.
yeah, it's annoying.
Yeah, Python it is.
Yeah, I really don't like the way it's set up. I wish I could just write more stuff in C, but it's kind of fine. Like,
Yeah, it's fine.
yeah.
It's fine. I mean, I have it working. It's fine.
I might
There's things
eventually
that-
do my own, like, we might do a like a Vec backend that is pure C when we like really crank stuff, because essentially the overhead will kill us when we try try to
Yeah.
do 20 plus million steps per second. You know, the M's have to be really, really fast for that. So we can do all that custom stuff. It's not that hard. Honestly, the stuff that's going to be the hardest at the moment, like the core algorithm work, is quite difficult, I would say.
Yeah.
That's probably the only part that's like genuinely, because it's
Hard.
all the research that everyone failed on for 10 years,
Yeah.
right? It's just they weren't set up to do it. We are set up to do it, but we still have to do it, and it's not easy.
This is like the part of the bitter lesson that people don't appreciate. Like the most important thing is that you maximize the amount of times that you run updates. Like you need to be running updates more frequently. And if your dev loop is tighter, then you can make literally that much progress. If your dev loop is 100 times faster,
Yeah.
you will make progress 100 times faster
Also,
than
1000x
anyone
faster,
else.
right?
Like even 1000x faster because you learn so much more. I mean, this is like one of like Elon has this algorithm that like he posts or has talked about it, and
Yeah,
I
I've
think it
seen
could be a lot shorter. But like cycle time is like one of those most important things, and like everything is actually, and I feel like everything is in service of cycle time.
Well, it's
Like
even more
deleting things,
important than
deleting
that
requirements.
because there's a human element too, right? Like if my dev cycle is long, I get bored and I stop doing it.
Yes, dude,
Like
exactly.
I
I
can't
want to
force
be
myself
playing.
to do it.
Yeah,
Right?
like in MMOs and all these video games, there's the concept of a game loop, right?
Well,
And
that's
dev
actually
loops
like a
should
fun loop, right? Is the key to that.
Yes, it has to be fun. It needs to feel like I'm gaming, you know? If like
Mhm.
if I have enough time to like look over to my screen, this is also why I don't like all this path that LLMs are going where the time to first
Yeah,
token
they-
is increasing because they're spending time thinking. It's like that's enough time for me to lose the flow. Like I want to be able to do things instantly. It might even be faster for me to like just code myself than wait for an LLM to think for 30 seconds. I'll think for 30 seconds.
Yeah,
Come on.
so the vast majority of my LLM use is just Super Maven single line completes because it's a typing buff.
Yes.
That's all
That's
I do.
literally, yeah. Actually, honestly, I'm probably gonna go back to just that. To be
Yeah.
honest, I might just do Super Maven. To be honest, because
It's-
that's my problem is like knowing, understanding or remembering. I need a memory augmentation for APIs. I know exactly what I want to do. Like I know that I need a PyTorch function that does this exact thing, and I will very specifically explain it. I don't need an LLM to like pontificate and like try its best. Like maybe I'll need it to like look over and like, hey, do you see any obvious bugs? Like as a reading buff, maybe for the thinking models, that makes sense to me. But in
Yeah.
general, like it's coding, like I just need it like instant, fast.
I tend to just do a lot of it by hand. Maybe it's old fashioned, but like I do think that you need to deeply understand systems, and that does take like constant repetition and practice. Because
Yes.
like the more you just outsource and abstract, it's the same as what happens when you abstract your own code, right? It's just you lose context and stuff
Yes.
stuff goes to hell.
So the way I use LLMs is a bit different from other people. I realize I actually read every single line of code that I write. Like I
Yeah.
have like I have my LLMs actually. I have my own NVim extension which has an LLM have context and output diffs, and then I can apply the diffs by pressing a hotkey, and I actually read every single line that it's inputting, and if I don't, it'll make mistakes and it'll do things that are bad. Because you know these models are like modeled after the average programmer. Like that's where they want to go. They want to go
Yeah,
to the
which
middle
is why I
of
don't
the
want them
distribution.
touching my code.
Yes, exactly.
Right.
Like I'm not like that type of programmer. I have to hide things from them because they will try to do things in a way that is average, and I'm not trying to be average. I'm trying to be weird. Like
Yep.
anyone is going to look at my
Well,
train.py
average
file
code
and
is
be like,
bad as well. Like
average code is this? Yeah, it's just not creative. It's bad. It's like you know when you turn on the TV and you see static. That's what it is. It's fucking nothing. So like for me, like when I show it my training.py file, it's like, oh, you need to abstract this out. No, I don't want to abstract. Like there's
Yeah.
a reason everything's in a single file, so I can edit it and jump around as fast as possible because I'm looping on this thing. Please stop
It-
fucking trying to quote unquote fix my code.
I've seen this so many times from like senior engineers as well, and like they do this in an RL context, and it never goes well.
No,
It just
of
never
course not.
goes well.
It doesn't
Like
go well. No, of course. Yeah, the
it's one of the
abstraction.
funny things, honestly, is like I can put all this information out there. I can make all my stuff open source, but like it's still just more useful for companies to hire me to do this stuff because it's like I outline exactly how to do it, and it still
Yes.
can't follow the map, right?
They're very used to the way things are done.
It really
They're very
it
used to-
requires you to throw away the entire way that you
Yeah.
normally do things.
Yes.
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 Abstraction need when you want to scale. You don't need abstraction to scale though. Like look at this.
No.
I don't need to scale when my code is 1,000 times faster than yours, right? Like
Yeah,
that
exactly.
prolongs I don't need to scale for so much longer. Like you need to scale instantly. I don't need to scale until probably I've already solved the problem because my
Yes.
code is just fast.
Yeah, people asking me like, "Oh, like, what's your infrastructure for Dingboard?" It's like, "Oh, it's a single GPU server that I haven't touched in a year.
Yeah.
I literally have not SSH to it for a year, and it just works." What do you mean? Don't you need to scale? It's a
No.
GPU server. It can serve a million users. If I need to scale, then I've made it. I
Yeah.
don't need to work anymore. Where like people don't understand how computers work, and they add these like abstractions and they try to over-engineer things. I think a lot of it as well is like related to status and how people look at themselves. Like everyone wants to feel like a big-brained engineer. No one wants to be like a
Programming is
Python
just
slash
nerd
C
snipe
monkey.
by default. It's
Yeah,
like
yeah,
literally
exactly. Yeah,
the act, like programming itself is almost designed to nerd snipe you. Like it's some of its language level. C is a lot better for this, I think. C kind of doesn't give you the shotgun to shoot yourself in the foot with abstraction. I mean, you can
Yeah.
spend your time fixing memory bugs, I guess, but at least you don't, like, the default in C is writing stuff simple.
Yes. I mean, like this is also I'm a big fan of Zig because it's a little bit like more ergonomic than C, but also just C. I never I don't think I've written a class like I avoid classes in general. I try to do everything as functionally as possible, just like a function calling a function. If I need state, it's going to have a big words that says program underscore state equals object, and then I'm going to use that as state. And I'm going to try my best to not mutate it. And at the end of the day, the only thing
Honestly,
that really matters, yeah.
I never got into functional at all, and I think it's kind of just as bad as object oriented. Like
Well,
I don't like mutable state is necessary for perf, and it's often the simplest thing as
yes.
well. It's the classes. So I tried to do like full procedural stuff in Python, and the result was just really, really stupid code, and it took me a while to understand why. And it wasn't that I was doing anything wrong, it's that the language itself, like languages force you into a specific way of doing things. So when people say the language doesn't matter, it actually does, because like try to
Yeah.
write C style code in Python, it won't work.
Yeah, that's true. I really hate Python, man.
You know, the language is, if you just say, fine, I'll write classes, I won't use inheritance, I'll just write basic classes, you know, it's not that different from just, if you have, it's not that different to have, like, the first param of your function is a struct versus you have a function hanging off of a class, as long as, you know, you don't just modularize everything to hell.
Yeah.
The thing I hate about Python is the tooling and the interoperability with other languages. And
Yeah.
what are all these questions here? Supply chain. That's not scale. Scale needs when you integrate with other systems or third party. Cool. Not only is my code 1,000 times faster, I also have 100 times less of it than everyone else. It's way easier to integrate like tiny amount of code than it is to integrate huge amount of code, because I can just rewrite little components wherever I need, and I can actually do that in like an hour instead of having to spend a whole bunch of time thinking about this big thing. And I do this constantly. Isaac Lab, Isaac's in this week, it's huge. So I haven't, this is why I'm saying low fidelity control. I don't want to get into high fidelity control unless it's tied to a big contract, because I would basically have to really get into, I wouldn't just have to get into like Isaac Lab and Isaac Sim to understand this. I'd have to go into physics and stuff, right? Because
So
it's pretty obvious to me that a 6 degree of freedom ARM does not need to be as slow as the current Sims are, just because computers are faster than that. But understanding exactly why and how they're slow would be annoying.
did you not just like look at Mujoko source and just rip out their function, their friction like code? It's actually pretty good code, to be honest.
Their friction code?
Like just generally the way they simulate things. Like I feel like you just plug that into Puffer and it should just work.
So high dim control should probably actually be on GPU, is the thing.
Okay.
Like, and by the way, you know, when I say it should be on GPU, the cool thing about Puffer, you can kind of just copy paste Puffer code into CUDA. CUDA's just C.
Yep.
We've kind of done that. Like, did you see the Puffer advantage function? It's literally just a piece of C code. Like, there's a C++ version and there's a CUDA version, and the CUDA version is just the C++ code, which is really just C code, pasted into a CUDA call. It's the same code.
Right. I feel like so do you ever feel angry that all these people are abstracting things away from you, preventing you from realizing how simple and easy things actually are?
Yes, well, which is why I've built all the stuff around Puffer, and I yell at people when they do that. Right? I yell at people for abstracting stuff. That's like the second most common thing I yell at people for. The only thing that I will actually really flame you over is breaking something critical because you used an LLM and were lazy and didn't understand what the hell it did.
Yes.
I see
I
it
I
again.
I I used to have a problem with making mistakes. I have a little trouble reading things, which is like not very good for a programmer. And I used to make a lot of mistakes when reviewing people's PRs or making my own PRs at work.
Mhm.
So what I learned is actually like I just like sit there with a pencil and I read code line by line before I merge every single time because I will make mistakes. And I think like a lot of people don't actually do that. Like they don't actually read every single line of their code, and you actually need to do that because not only LLMs hallucinate, but also humans. Humans also
Yeah.
hallucinate.
Yeah, I tend to YOLO merge stuff a bunch and fix it later. The one time I got really bitten by that, somebody introduced a like only happens once every many hours memory corruption bug in the Python garbage collector. That was awful.
Oh,
That was
oh.
the worst thing I've had to deal with since doing Puffer.
I find like C, just writing things in straight C is a lot easier to avoid bugs like that because
That was the
everything is very
Python C
explicit.
API.
Yeah.
Like that was the Python C API, right? It is C, but it's like they have a garbage collector in C with like horrible crap
That's
associated.
awful. I hate complexity, dude.
Yeah.
Complexity is the devil. I hate it. Why do people keep on adding a complexity? Stop.
So
Stop.
actually, the thing that I would really like to have, which have you ever used Python?
I know.
So Python is like you can write Python and you can write C in the same file.
Oh wow.
It's great in concept. In practice, the compiler is a buggy mess and like gives you tons of crappy errors. But if you had that but good, like the ability to quickly switch between something for like you don't want to do stream processing in C, for instance, like just like basic stuff. It's a pain in the ass, right? You don't care if it's fast. You just want it to work. You want it to not be a bunch of lines. Easily switching between these two things would be way better, but it just doesn't work at the moment. Like you have to go through the Python C API, which is a bloated, buggy mess.
Every time you add something from the outside, it's usually a buggy, bloated, buggy mess. Like dependencies are really bad unless you can actually read all the dependencies and change them yourself.
Yeah, I mean, it's tough. It's like at some point, it's like I don't want to write my own graphics engine, right? I want a lightweight one. Okay, Raylib is perfect. It already exists.
I mean, the thing about Raylib, and I think there's also Sokol and all these like graphics libraries, is that they're super lightweight. Like you can actually just
Yeah.
go read the header files. Like
Yeah, no, we
that to
do
me
as
is
well.
less of a dependency than just having someone's code as reference, right?
Just fix for loops in Python.
Yes.
There's not really a way to fix for loops in Python. Like, do you see if you go look at the Python C API, you'll see how much happens every time you do any operation in Python at all. It's just always going to be slow. Like literally every single thing, every variable, no matter what it is, gets wrapped in like a big Py object where like everything is abstracted so that everything can be type independent. So you have, your dynamically type. It's just a mess. And then one of my big pet peeves is like people try to like reintroduce types into Python. Freaking hate Python type-ins.
Yep.
That drives me nuts.
That just doesn't work.
People
It
keep
doesn't
trying
work.
to PR like types into Pufferlib as
Yeah.
well, and
Why?
it's just no, I'm not doing it. You can't make
Yeah,
me.
no, just
You can't make me. They're not enforced. They just add stuff. They're not even enforced, all right? And they don't make the
Yeah.
code faster. If you want
I
types,
feel
write
similarly
C.
about TypeScript and JavaScript. Like
Yeah,
just
I
use
don't-
JavaScript. Like
Yeah, I don't like TypeScript at all.
think about like how sick in the head would you have to
Yeah.
be to come up with an idea like TypeScript? We're going to have a language that compiles to JavaScript,
Yes,
which is
it
a
sucks.
like what is yeah.
The
Hey
thing is,
Joseph, I
like
gotta go.
the
and-
people who suggest this to me as well, it's like there's certain people I know who have built impressive things, but just have a very high density of just horrendous engineering takes. So it's like, yeah, you built the thing. It took you 5 times as long, and the code was 10 times as complex. You did build the thing, so you're smart, but you've kind of nerd or sniped yourself into a way of building things that's just not good.
I think the difference between people who end up doing that and people who really avoid doing that is people who are really trying to get things done as fast as possible, like actually just trying to get the actual thing done as simply as possible and as fast as possible, and like maintain that speed throughout. Like you end up going towards simplicity and avoiding complexity. It's what Terry, King Terry the Terrible had said about like, people like complexity because it makes them feel like really smart and you feel like a genius, but simplicity is like actually what people, real smart people appreciate.
The thing is, simple is not easy. Like,
No, it's
simple
not
does
easy.
not mean. Do you know how long? Do you know how much work it was to get even just like the puffer trainer to the length that it is? That's like the 5th generation of a config system. Even
Yeah.
for instance, right? Like, why is it ini files? Why isn't it YAMLs? Why isn't it like some sort of like static spec thing where you can't make errors with it? This is literally the 5th generation of stuff.
Yeah.
I think
I-
that
actually, like-
config system was harder to make decent than like some of the actual RLM puffer.
The way I have it set up is I have a Python dict. I've actually ripped out the config system and I just like have a Python dict, which is the config. And I just pass it to the trainer directly.
So the reason here is we do algorithm research, right?
Right, okay.
So when we're doing algorithm research, like we need to be able to run stuff on tons of different environments.
Right.
Because like there's hold the algorithm constant and then there's hold the environment constant. These are two different
Right.
modes.
Yeah.
Right. So like being able to quickly and simply test the current thing, whatever state it is in, on a ton of different environments is really important.
Yeah, like keeping it modular like that.
Yeah, so I don't like it. I don't like it either. We've tried like just pure dictionaries before. The ini files have just been better for us.
Okay.
There's also like we have it such that there's like a default file, and then anything you put in the inis just goes on top of the defaults as well. So it's like most of the time you just need a stub. Yeah, I don't know. Maybe we will eventually find a better way of doing all this crap. There are too many moving parts still, but
Part of my motivation too is like I need to see everything and actually be able to step through it to understand it because this is all new to me, right? Like
mhm.
I'm running PyPlots on these things. These like I don't really know what entropy means in the context of reinforcement learning, to be honest. Like
It's
I
how
can
much
kind of
the
guess
model
what.
is like. It's how much variability there is in the actions that it's taking.
Interesting. Okay.
Like how if it's is it always perfectly confident and it's always taking the action that it's predicting, or is it like sampling from is it like yeah, half the time I'll do this, half the time I'll do that, right?
Yeah. Okay. That makes sense.
RL can learn
I'm
that.
gonna
You can learn stochastic
print-
policies.
I'm gonna print all your stuff and then all of.
You're gonna have to get the references if you're gonna take that with you because it's a heavily referenced article, so it's refers to
Okay.
like most of my other articles and then like a decent little stack of academic papers as well.
Okay, got it. I mean, I'm just gonna print a giant stack. I mean, I'll be camping. I won't have internet. I'll actually read everything, and I still need to make progress on this.
The
I need to
blogs will
go.
make sense.
Actually,
The academic papers will take more work, I think, to read through.
I've read I've read a lot of academic papers, so I can kind of get through them pretty quick. It's just the fundamentals for RL I don't have yet, so I'm gonna read some books and just try to get the fundamentals down.
The most
I gotta
important
go.
paper in RL is OpenAI 5. Yep. See you around. Thanks for dropping
you.
by, man.
I appreciate it, and hopefully by the end of this month I'll have a flying hat on my head, and I'll try to
Hey,
get
let us
some,
know
get
with
some
like the
code up.
beta FOV stuff because we're trying to do the same thing with that at the moment.
Yeah.
Same thing.
Have you guys ever thought of getting images in the training loop? Have you
It's
considered
really,
that at all?
really, really slow. What we were gonna do is we were just gonna do some basic perception thing to like, find where rings are or find where targets are. Just basic ass classic CV stuff.
Right.
Because
Okay, I think-
images slow you down immediately 1000x minimum.
That's the move, I think, man. I think that's the move, to be honest.
What is?
Like generating the images of what you're about to do. But like, for example, like you get a bounding box and you set the goal to like make the bounding box bigger if you want to hit a target, and you just like noise it up or something in the simulation, and then
it's state estimation, right? It's just state estimation.
Yeah.
Now, we're gonna do that. It'll be fine for this. It's not great for robotics. Oftentimes they have images there. People do like GPU batch renders, like tens of thousands per GPU, but that ain't millions, right?
yeah. What are the Mardona? I think I saw some repository called Mardrona.
Madrona, yeah, Brennan Shackleton, I know him. He does good work, but it's sometimes actually some of their stuff they can get rendering hundreds of thousands, but it really depends on what you're working at.
Okay.
That's what I would
Interesting.
do though. If I had to go that route, I'd basically go find what is the minimal batch render I can use, and then I would keep the logic in C, and I would basically just take the state from C, and then in like before it goes into the neural net, already on the GPU, it goes through the batch render to produce images. That's what I do.
Okay, yeah, and I think what I'm probably going to end up doing is figuring out how Madrona is doing that, and then just like implement it myself. Because I want to see
Yeah.
like how it would behave with an image embedding model. I feel like it would just do well, to be honest.
Maybe.
I don't know. I don't know what I'm talking about.
You're gonna
Yeah.
take a 10x hit in the best case. I will tell you. You're gonna take a
I will
10x
buy-
perfect in the best case.
I will buy 10 times more GPUs.
Yeah, that's what you'll have to do. Yeah.
All right, man. I really appreciate all the hard work and
See
the
ya.
rest of
Thank you.
you guys
Yeah,
as well.
thanks
See you
for
later.
dropping
Yeah.
by.
All right, peace.
Bye. That was fun. How do you do testing without abstraction? We only test like very small. We don't have a huge amount of test coverage, frankly. We have very simple code, and then the super fiddly bits that we know are going to have issues, we write some like extra stuff on that. We don't even like have them in CI or anything though, and it's still like you can look at Pufferlib versus other stuff out there, and it's not like Pufferlib is super fiddly and always broken where the other stuff isn't. It's like stuff is broken at least, at most as frequently as it's broken in other places. Good convo. Thanks, Jason. Yeah. I seem looking for GPU deals. Yeah. That's why enterprises use abstraction. It's bad. I don't care what the reason is. It's bad. Like, in RL, it's especially bad. Like, they write code in a way that it's going to break for this purpose of testing it. Like, literally one of the most common things that I do when I'm working on new stuff in RL where I have a big repo that's like just a mess is I take all the files, I paste all the files together, and then I just start deleting redundant bits recursively. And usually I end up with like 1/10 of the code that I start with because it's just all crap. We were gonna actually do drone stuff today, right? My notifications are blown up. Okay, the general guide is here. And this one's here. Cool. That's doing quite well. Drone stuff time? Yeah, drone stuff time. 10.2 already. It's crazy. A lot of growth this week. That's good.
I think that was at least 100 followers in one stream, which is kind of crazy.
Yeah, it was, a week ago we were at, I think 8,000 something.
Yeah.
It's going to bring a lot of new people to RL, which
Cool.
we need help with this stuff, man. We definitely need help with this stuff. We're going to eventually need people who can help on the algo side at some point, or at least people who can help with the other stuff I'm currently doing, so I have more time to do algo stuff. But yeah, I'm realistically, in order to make RL be where it needs to be, I'm going to have to do a whole bunch of algorithm side work. But like for Puffer to be where Puffer needs to be, I need to kind of make some solid applications of this first. So that's what I'm doing at the moment.
Yeah, very
Not
true.
to say like we are going to get some research benefits out of all these applications as well, right? But it's the thing that we're not going to get is like the core algorithm work. That stuff is usually much better done in isolation. What's the other stuff? If you look at the guide that I posted today, the RL guide, sample efficiency is a big question right now, and it's probably the most covered topic in reinforcement learning, but the coverage is all really bad. So essentially there are minimum of 3 competing ideas on how to do sample efficient learning, and it is unclear to what extent any of them work, if they work, how they work, why they work. It's off-policy learning is one, model-based is another, search is another. There are probably some others that I haven't even thought of in there. It's a whole mess. If I had to guess, I think it's like, it might even end up being problem dependent, frankly, I don't know. But I think even with the stuff we have now, we can solve really like important problems in a ton of areas with what we have right now. Are these algorithms that currently exist or new ones to be discovered? So what it probably is, frankly, it's going to look like me going through the last 7 years worth of DeepMind research, ripping out all the fancy bits that make the algorithms seem cool and keeping the bits that actually make the algorithms work, and then running tens of thousands of experiments to test all that. That's basically what I did on PPO for the 3.0 release that made it work. It's going to be that at much larger scale, though. Is there a summary of different complex topics and layer counts and training time used? Complex topics, the 3 that I just mentioned with references, are in the guide that I posted today. Layer count and training time, that's like almost completely unexplored in RL. We just don't use deep models almost ever because they don't work, and we don't really know why in general. To be fair, we also know that we don't actually need deep models to solve ludicrously complex problems in reinforcement learning. And I think that's also unclear, right? Like, shallow models kind of don't work in other areas. Like, to solve perception tasks, for instance, like, you really need deep models. But shallow models solve ridiculously hard problems in RL. Wait, did Yaxine post like 10 times while we were having that conversation? I think he did. Oh no, okay, that's all since then. Holy. That's funny. Cool. We don't use deep models because too many local solutions. See, that's not true, is the thing. What does too many local solutions mean? You mean local optima? Those don't exist. That was a 2015 era deep learning nerd snipe that we thought that our stuff didn't work because of local optima. Saddle points do exist. Momentum fixes that. Local optima don't really exist. They do exist in problem space for reinforcement learning because it's a low-dimensional problem, but that is independent of the architecture used. That's the technical explanation of that. Linky wants feedback on that PR, but we're going to do drone stuff right now. Finn, Sam, are either of you still here?
Yeah, I'm still around. I think Sam will be, I don't know, maybe 45 minutes and he'll be back.
Yeah, I know we sort of got sidetracked, but that was a cool
Yeah, that's all right.
conversation, and I think a lot of people will get interested in some of the stuff we're working on from that. So, hey, maybe we'll even have more people helping out with this stuff.
Yeah.
I guess one of the things I should say in case we have new people here is if you have experience in another field, that's also really helpful with RL because we're looking for all sorts of problems in different fields where people just kind of haven't thought of building sims and trying RL. We build lots of sims. Okay, so the thing that I was going to tell you guys on the drone stuff is if we just make every problem some form of go to target, that should at the very least cover the rings, like the ring task, and the all like the flag tasks and other things. So what do you guys think if I make one big sim with that, where I try to keep the complexity as low as possible? I have like the drone stuff independent, and basically you can just load in different tasks, right? So like you have an end that can put rings, it can put targets or whatever, and we just try to do that.
Yeah, that sounds good. It'd be a lot better than having 10 environments with marginally different tasks. That wouldn't be great.
Environments, yeah. Well, I don't always know, right? Sometimes it is better to just have separate stuff, but I'm thinking like, do we just get better results out of training on more different stuff, or should we like only train on racing?
I see. Yeah, I don't know. That could be cool.
It's usually the case that like when you have a few different tasks, it is initially harder than one task. But then when you get like more and more training diversity, it actually makes it easier. So the best number of tasks to train on is either one or as many as possible,
Right.
if
Okay.
that makes sense. That's usually
Yeah.
how RL, like curriculum learning in RL works. Right? It's kind of like, you know, if you just try to like learn just enough of a field to solve one problem, for instance, that's generally pretty doable. Or if you try to like, if you want to solve like 5 problems, then you're better off. You just got to learn the field, right? It's one of those.
Yeah, yeah. In terms of the sim to real stuff,
Yep.
me and Sam we're a little bit busy for sort of like the next 2 weeks, but then after that we've got like an entire month of just nothing. So most of the stuff will probably be done in sort of late July, August. But there's a bunch of physics stuff to be added until then. Should still be busy.
Yeah, I mean, I'm gonna try to get like some really solid sims, and then it's just a question of how hard is it to throw on the hardware. I mean, it might be the case that we just throw the commands on the hardware and it works. I don't know. The perception stuff is going to be a little different. I'm probably going to have to get myself a drone kit as well to help work on that, because we do need to do state estimation of some type, right?
There was a paper I read from Zurich where they just used the camera, but yeah, state estimation probably not hurt.
Well,
Sure.
if you learn end to end with the camera, again, your training gets 1000x slower,
Yeah, yeah, yeah.
right? So that's just not fun, ideally. Trying to think like what's the simplest thing we could throw together to make it work initially. It's probably just like the hoops or whatever, because the hoops are almost like QR codes, right? It's kind of like an off the shelf thing.
Mhm.
I don't know how you get like distance to those though from kit, like, 'cause it is a depth. It's like a depth estimation as well, isn't it?
Yeah.
Hello, I'm back.
Oh, hey
Hey
Sam.
Sam, we're just
What
chatting
have I
about what to do
missed?
with this, with the drone stuff. Like, I think
Right, okay.
so. I can get us one sim that does the swarming and does your stuff, and it'll be really easy to load specific tasks in or to train on all the different tasks. Like, I can get us cool demos out of that for sure. Now the question is going to be to get it on the real hardware, right? There are two things, right? There's sim to real gap, and then there's the perception part to actually estimate state.
Yeah.
Yeah. I think the latter will probably be the more difficult part, but I'm not sure.
The state estimation.
Yeah.
Yeah. I mean, what's like the most basic thing we can do for that?
I mean,
Um,
accelerator, just
yeah.
bones.
The drone kit you're using, is it possible to 3D print drones? Order a bunch of batteries. You need motors and cameras and sensors, and like you need chips. The only thing you can print is a frame. And the frame isn't even expensive. Like at that point, you're just causing yourself a whole bunch of assembly work for not saving really any money or anything. The only reason we would like 3D print stuff is if we wanted to play with different form factors or something.
Mhm.
Yeah.
basic
Well, I
drone
think
state
with
estimation.
there was that paper you sent me this morning as well, Finn. It was from Zurich again. What was that?
What, the champion level drone racing one?
No, the first one.
Oh yeah, the perception only one. Yeah, that
Yeah.
seemed pretty cool.
I mean,
If we can get it to not
could.
super
It's
slow.
so hard. Like getting that to sim to real is way harder, I would think. Is the annoying bit because like when they do that in robotics, right? They have a pretty clean deployment setup for it, where there's not really a bunch
Mhm.
of visual noise. Getting a sim to real when like you have a realistic moving background and such, that's
Yeah.
I think that's gonna be pretty obnoxious. It's not even on
Well,
real work either.
ideally you'd just segment the image, right? And then it's kind of doesn't really matter what the background is.
I mean, you can do that.
Might be
You really
slow,
want to
but
just know where you want to know where the target is. Like that at that point, you're not doing state estimation at all. You're doing end to end.
yeah.
The only way we could do that, right? It makes the project much more complicated. It's the thing I was telling Yaxine, which is the batch renderer. It makes it a lot more complicated.
Mhm.
I think my preference here would be, is there like a really basic state estimation thing that we can do to get something to work first?
Uh, yes, ish. Let me see what they
I
do.
mean, isn't best case scenario the kind of sim to real gap is so small that it doesn't really matter. But I think that's kind of
It's not the sim to real gap issue,
Oh.
right? It's the state estimation problem. So you need
I
to
think
know
I
where
think
the
what's
targets are, right? We're training on like the target is
Oh,
X
right,
distance
okay,
from
yeah.
you. You need to know where
Yeah,
the
okay.
target is. I mean, if you instrument the targets, it's easy, but that's cheating. Now you can actually, when we were
Yeah, I
doing
was
multi-agent,
thinking of something else.
we actually like the flag demo for stuff, for instance, like that stuff we can actually just cheat because all we really need to know is where all the drones are,
Mhm.
and they're allowed to talk to each other, right? That's not cheating. They're all your drones.
Yeah. Well, the kind of, I suppose, easy but very expensive way they did it before. Did they not just have like 50 cameras in the room where they were?
yeah,
Um,
what one of the papers did, which is kind of
they
crazy.
just had like a massive warehouse filled with cameras and the hoops and stuff, and it could just track them.
Yeah, that's super cheaty though. Like,
Yeah.
Yeah.
that's not gonna work anywhere else.
Yeah.
Yeah, it's kind of a bit silly, really.
I think accelerometer is probably the
It's
way to
I
go
think Air
at this point.
65 crypto. I mean, at that point, you just like record the positions of, all the targets and just give it to the drone, right? Like, there's no reason to even have any perception.
Yeah.
We could, well, you don't know your absolute position is the annoying bit, right?
Yeah.
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 You can like, you have to integrate from your starting position, and I'm pretty sure that type of stuff is like really noisy, right?
Yeah.
If you just like double integral your acceleration, it's really noisy.
That's what you were trying for our like original drone before we had the new one, and it just didn't work at all.
Drone to drone communication might be cheating if you consider somebody might be trying to interrupt the signal. I don't know, like, how many things are there? I guess technically they can jam the radar without like EMPing the drone. If you want to think of it that way, so you can interrupt communication and still leave it online, I guess technically. The state estimation thing is is tough. I really don't want to do the batch render thing just on our own, you know? Like I don't want to just like do the batch render to make a cool demo work, right? Like the batch render things, if we want to do perception based stuff, that would be part of a larger project in my mind.
Okay.
Yeah.
Depth camera, yeah, we
Yeah.
can get like a depth sensor, I guess. But I don't know how well that works because like okay, you have a camera, and let's say you're basically doing QR code stuff. That's off the shelf, right? Because it's the targets. They are painted with something so you can recognize them. That's pretty standard.
You know, ages ago, Finn, that like depth perception thing that Armin had running on his laptop.
Oh yeah, ML.
How many frames per second was that?
Not enough.
Not enough. Okay.
I think I mean, on our computers, which is not ideal, obviously, it was like what, maybe 3 FPS.
Okay.
There are faster ones, but
Oh, you
Yep.
mean like the camera-based stuff? Yeah, that stuff doesn't work.
yeah,
No,
it was never.
I've worked on that before. That's way too slow. I mean, maybe if you really tried, you could like get a version of it inference only. You're not going to train on anything coming out of that though.
Yeah.
Yeah, absolutely.
I think I sent. Sorry, go on.
I was just gonna say I'll put there's a kind of a cool graphic from one of the Zurich papers that I've just put in dev.
Mm-hmm.
If it'll actually send about how they do their state estimation. I mean, it's quite brief.
Is it like super complicated?
Yeah, I mean, it's complicated enough that it would be
Great.
a bit of a pain.
Let's see. So image.
It's probably doable.
I mean, we've kind of got to get it working on like
Is it? Wait, is that
fixed rings
super
before we.
Yeah, that is.
yeah.
Because it's trained, right? It's like they're kind of just putting this Kalman filter. Yeah, so they're training on essentially downsampled images. This is basically the same thing as what if we just train on images with some pre-processing. So that's super slow. That's not exactly state estimation. Right?
Yeah.
Is there, if we instrument the things, is there like a how hard is it to get a proximity sensor that gives you a reliable estimate of how far you are away from another sensor? How is it done?
I don't think
paper?
it's exactly the same thing, but they used a. It was on the drone websites when we were buying the parts. It's called the Intel RealSense camera, and then they just like had that connected to some onboard compute thing. I think it's basically just a kind of an infrared based depth sensor, pretty much.
Infrared based depth sensor. Well, you need to also know that you're looking at the targets.
Yeah. But I got the gist that going down the route of these Intel cameras means you'd need to buy one of those kind of NVIDIA compute modules as well, and it's just a very expensive
Well,
rabbit hole.
You know, initially, guys, we could just punt on it for now and just be like, hey, let's get the thing to run on the real drone.
Yeah.
We have relative targeting, right? So what we could do is we could just make a thing, right? Where on your laptop you can drag around the target or whatever, and it'll just go to that. Because you tell it, all right, the target's this far away. You just do the basic integral or whatever. It doesn't collapse because it gets reset every target.
Yeah.
So then, that should basically let you control the drone, and it should be able to go from its current position to any other position. pretty easily. And like we can already start throwing together some demos before we have to do perception. Like my highest priority here is to just get the neural net running on the drone in a way that it's actually flying
agreed.
correctly, right? Like the perception thing is kind of whatever. Like in my mind, this is like all the application specific crap, right? Like I think that even before we touch perception, we should be able to come up with something cool enough. Like, yeah, like what if we just give it the if we just like give it the course, for instance, right? Like literally
Yep.
just run the exact policy, it's gonna do all sorts of cool aerial maneuvers, isn't it?
You'd hope so, yeah. That'd be
I'm pretty sure for these drone racing things, their policy is literally just on that one course anyway. So at least
Yeah.
then we know that we're
Yeah.
at least as good as the current best is.
Well, depending on what the gap is, like what you could do is you could just like set it up and measure, right? Like put a couple of hoops around, no instrumentation, no perception, and like if the thing
Yep.
is accurate, it'll just fly through them if they're in the same position as it thinks. I'm sure that
Yep.
like it'll diverge eventually, but my priority here is I don't want to make you guys do a bunch of boring ass annoying perception work. Like the goal is to get something cool running on the bot as quickly as possible. I think that'll be way more interesting for you, and that'll already make like a really cool demo because you'll get like just flying the course in midair will get you all sorts of like interesting aerial maneuvers, right?
Yep.
yeah.
I think that should be really cool. And then once we've got some cool stuff, then we'll know if we need
Yeah.
what level we need perception.
I almost wonder. Well, this would probably be a pain in the ass if you just like throw some AR goggles on and like see the course, like and have it like run an AR course, so we don't have to actually
Yeah.
have the right.
Yeah.
That would be kind of cool.
Well, we've kind of got a good controlled environment to do the drone in because we've like booked out the exam hall basically, which is like 500 person capacity. So we've got a massive hall to fly it around in at
That's
max speed.
awesome.
So we can probably even like stream some of it from our phone or something, just so
That'd be awesome.
you guys
Yeah.
can see.
Infrared probably won't work due to distance constraints. Maybe more LiDAR. Yeah, we don't want to really get into that crap before we can avoid it, right? Like
That sounds cheap.
the goal of a lot of what we're doing is to really showcase the tech, and then like application specific tie-ins to tech. We can do that as part of like formal engagements with companies and clients and stuff, right? We want to the core stuff that we do on our own is mainly like keep it as we want to like show off as many cool things as we can that are like close to the tech. And I think this qualifies because this will be sim to real, right? This is sim to real, like flying the course in the air. The perception is a completely independent problem, right? It's a problem we know how to solve if we had to, right? They're two different approaches. They're state estimation. It's literally been done already, right? It's just annoying.
Yep.
And then there is like high-perf batch simulation, right? It's high-perf batch sim for camera. That's like another thing you can do.
Yeah.
It shouldn't even be that crazy expensive, I would think, for something like this. Like Madrona, with Madrona you could get a couple 100,000 frames per second, and we could just scale GPUs. But like we literally don't need to do that initially at all. Let's just like get the drones running around doing all sorts of crazy stuff autonomously. Right?
Did you find a USB A to A cable, Finn, or shall I get one ready to go?
I mean, I can look in like 10 minutes, sure.
Okay.
I think I've got
I
one.
think that's the last thing we'll need. Oh, we still don't really need to get video back from the drone's camera yet, do we? Because that was the kind of the component we skipped out last time because there was no stock.
Not yet.
I
Not
think
with
when
what
I
we
looked the
have
other
at the
day,
moment.
yeah,
I think if you guys
Agreed.
can just get, and this way it's not going to take months as well. I think if you guys can just like, can we run the code on the drone? Can we get it to fly around and do like what looks like running the course? Just like watch on your, basically just if you can see on your laptop, like this is what it thinks it's in the sim, right? And then you can like physically look at what the drone is doing and see that it like looks like they're doing the
Yep.
same stuff, right?
Yeah. Yeah, that would be really cool.
You can quantify
Well,
the
I'm
gap there as
hoping
well.
we can, well, hopefully we can get the model running on the drone like kind of
Yep.
same day. I'm hoping kind of the actual hardware part of it shouldn't be too bad. And all of this drone firmware plays nicely, but we'll see.
Yeah, ask
Yeah.
Yaxine about the, because there's like the general software that's used for a lot of things. He's played with that before, I think, from on different problems.
Yeah. We may have to mess
Mhm.
around with what the actions look like. I don't know how nicely the drone will play with just giving it RPM commands, but
What do you usually give it?
It sounded like you can do
there we
that,
go.
but
Yeah,
it's a bit
slightly
it's,
less standard.
yeah.
But either way, it should be fine.
Yeah, I'm just that's the thing I'm kind of slightly worried about because when we were doing it with the old drone, simply just sending commands to the drone programmatically was pretty difficult. Just
Yeah, so the hope is that
because
it's not now with this, and if it is, we'll have
yeah.
to give you something else.
hmm
At least
Yeah, I
the
think
hope
the
is that
problem.
this one, at least, the hope with this one is that it's not going to break in 5 minutes, at least.
Yeah.
Like, because the ones they use for racing, they have unshielded rotors. So, like, you crash that thing at any speed once, it's broken.
Well, the transmitter we got this time is kind of you can just use with any drone, and it sounds like the transmitter we've got is good and is also pretty good for sending programmatic controls. So hopefully, as that's kind of the key link this time, the actual drone shouldn't really matter.
It's an Air
Fingers
65,
crossed.
Johnny. The guides are doing pretty well already.
We were looking at that earlier. The list of papers look good. I need to have a look through that and see if there's anything I've missed out on.
What list of papers? Oh, the ones. Yeah, that's like general. There's general RL stuff in there. It's really the best way
Yeah.
to know. To like learn this stuff. It's not. It's not the material that you'll find pretty much anywhere else. Also, it's like I have a very different approach to a lot of this stuff, and it's honestly a lot easier. Because if you have a really strong math background, like yeah, you'll just be fine doing all the formal stuff. But the thing is, it's not going to tell you how to actually do RL because none of the formal math actually works. And second of all, like if you don't have a really good math background, it's going to be really hard, and you're still not going to know how RL works. Whereas if you just like are able to, if you're able to do the material that I've sent, like it relies more on programming. It's more accessible in a sense because maybe your code's not as good as mine, but if you stick to the way that I've suggested you do things, at least it'll be passively good. And you'll actually get RL working. Like you will provably have RL working on a new problem, a new environment that you've made, several new environments of increasing complexity that you've made. And you fill in the theoretical gaps along the way. And the theoretical gaps you're going to fill in aren't even the same as the ones in the formal, if you just read Sutton and Bardo, for instance, because it's like, those are just really old and bad models of a lot of problems.
Yeah.
It's mostly knowledge of like, you know, newer, more empirical models and what they're based on. Okay. I'm gonna get you guys a sim right now. That's gonna be the goal. I'm gonna see if I basically just merge the drone swarm and the drone racing environments.
Yeah, I think that would be good. I really like the way you've done it in the swarm one at the minute, where you just kind of just switch between them. I think if we just go with that,
Yeah.
that'll be great.
It's a little annoying because like the rings are gonna be task specific, and I
True.
also was
Yeah.
gonna put like obstacles at some point. I think it would be cool to put like obstacles. You know, we could just spawn like random spheres some distance away from the
Just in
rings.
case it's useful, I'll put in my original like Python collisions code in the development channel because
Yeah.
that supports planes and
Well, planes are
stuff
harder.
like that
The
as well.
spheres are really easy, right? It's just a
Yeah.
radius check. Right.
Yeah, I sat and worked out all of the linear algebra for it, and it does work. It's just not very
The
fast
planes,
'cause
yeah,
it's still quadratic.
it's annoying hard. Yeah. I'm not envious of that stuff.
Yeah, it took a while.
You know, there's not really a great way to do planes. Cubes you can do very easily. Cubes you just do a bounding sphere, right?
Yeah.
And it's like pretty close.
But the original kind of plan back at end of last year, probably with drone, was getting it to kind of navigate environments and stuff. We've kind of switched more over to kind of the race. It was kind of more of like an exploring drone before, I suppose.
Yeah.
We can do that super easily in Sim if you guys want to. I mean, think about it. We
could
just
do.
add a task that's like get to the objective, and you're basically navigating through an asteroid field, right?
Mm-hmm.
The only thing is like the we have to change the obs a little bit because it would be like we'd have to know. Probably what we should do is there should just be like a ring buffer and like a nearest buffer or something. So you can see the nearest rings because they have, you need to actually know the normal direction for those. And that's needed for racing. But everything else is just like an obstacle buffer. So like other drones are obstacles. Asteroids would be like obstacles. It's just like, hey, this is where it is. This is how big it is. Don't hit it.
Yeah.
I can do it. I can get something like that working. So then that would be like a navigation type thing. Like, you know, get to this goal on the other side of the map and don't crash into any of these obstacles.
Mm-hmm.
Cool.
Yeah, I'm looking back at the collision code now, and there's some stuff which I'm not fully sure about now I look at it again because it is 6-month-old code, but I think it should be all right.
Yeah.
Oh, the other thing we did have originally, which could be useful when and if we do perception stuff, is we were able to train it to look in a certain direction as well as moving to a place, so the camera's kind of facing in the right way.
Yeah.
That might be useful.
So that I can actually, that I'm not as concerned about because all I would have to do for that is I would take the current state-based observations and I would make them only appear within a cone of vision. Right?
Right, okay.
So, and then
Right,
like it's
okay.
still the same state estimation problem as before, right? Like you still have to just do the state estimation, but then it should basically learn that it has to turn towards stuff to see it automatically. So that's not
Yeah,
super hard.
that's true.
That's
I think
actually quite easy.
we were hoping, were we trying to get it to fly backwards or something? So I can't remember.
It has to spin, and it takes it a while to spin. So it's like
Yeah.
getting it to get new information like that can be a little tricky. Not that bad. Okay. Article's got 28,000 views already. Listened to like what 2-3 hours ago.
Nice.
Cool. Well, hopefully we get a lot of new people into reinforcement learning with this, and I will have to just work on stuff. Getting like work on.
Yeah, when did
It'd probably be. Sorry, go on, Finn.
I was just gonna ask when did Yassine find this stuff? Like what? What's the story there?
When did what?
When did Yassine find this stuff?
Oh, it's one of my other followers apparently just like added me with Pufferlib when because like he was trying to do some RL thing. He just hops around and does a ton of different things. And one of my followers like said, "Oh yeah, you should check out like Joseph's Pufferlib stuff."
Oh, nice.
So I have grassroots marketing. We just have
Yeah.
Pufferlib used. Like we have some people that use Pufferlib and they like it apparently. So we're very happy about that. Pufferlib could be way better than it is now, though. It can be way, way better. We're going to do some applications on the current version before I really go back and look at that. Okay, so I'm gonna go use the restroom and grab coffee real quick, and then I'm gonna see if I can actually code up the single sim. I think I should be
Okay,
able to
cool.
make a decent dent on it today.
Nice.
Technically, we could do. I'm gonna see if we have like entirely different step functions per task or what, because like technically. No, I can't. I can't actually make the racing ends multi-agent because the targets change when the drone goes through them. That would be a cool thing to have, like a ton of drones flying the course. But
Yeah.
I mean, at least because it's PCG'd for now. Like, if you were to just put all the rings down at the same time, then you could do it.
Well, I mean, we could do that, right?
They are all
The-
created at the start.
Is that
It's
worth
like a
doing?
set buffer.
If we just put all the rings down and then it just when it resets the whole environment, it resets the course. Like, I could put all the drones in and just like have them all do the same course at the same time.
Yeah, it does that already.
Yeah.
It just only shows you them 1 by 1 or 2 by 2, I guess.
Okay.
Shouldn't be too bad. You just have to keep track of which ring each drone is at.
We might need to make the map a bit larger as well because like the collision checks for everything.
Yeah.
It's 10 by 10
I think
meters
we've
cube
kind
now.
of. Yeah.
How
We've
big
just
is the
got
actual
kind
board
of
that they
like
use for
the
this?
Zurich people.
Yeah.
Pretty big. I'm not sure exactly, but bigger than 10 by 10 by 10.
Yeah.
It's
a lot
probably
bigger.
like, is it like 50 by 50 by 10 or something?
I'd imagine so, yeah.
All right. Well, I'm gonna see if I can make us something cool out of this. The other thing I was thinking about is like if I wanted to put all the different environments like together, so you can see some drones making a flag, some drones doing racing and whatever. Collision gets obnoxious if I do that, though. Collision gets super obnoxious.
I've just found it online. The track is 7 square gates arranged in a volume of 30 by 30 by 8 meters, and the total track length is 75 meters.
30 by 30 by 8. Yeah, we'll just match that then.
Yeah.
Cool. All right, I will try to just get working on this. If you guys can get the drone working, I will see if I can get like a super stable, super general, like whatever drone, whatever course demo thing. And like if the goal is like if we just get a really good policy that does this, then any perturbation of drone and course should just be solvable instantly. So you end up with like really robust self-correcting policies if you do this. That's the idea.
We were working today a bit as well on improving the kind of like integration part. So using, is it RK4 fin instead of
Yeah, that's
Oilers?
the one.
Yeah.
That would be
Us.
yes, that would be good. Please do not do forward Oiler on I actually
Yeah.
do not know how stable RK4 is even going to be. Like you guys are probably gonna want to write something to quantify that. Because like
Okay,
the
yeah.
measurements
Yeah,
are
wait.
gonna be noisy.
It seems like the code for RK4 is going to be pretty
That's about 5 times as
massive
long.
anyway.
Yeah.
Isn't it? Isn't it pretty short? I thought RK4 was pretty short.
I mean, I think it depends how you write it, but it's not short for sure.
The
Maybe like-
formulas are like. This is right here. Is this not it?
Just
Analytic
let this
answers
stream.
from-
Hold on, there's a stream delay.
Oh. Or is it just like RK4 for one specific formula? I don't think it
Yeah, it's
is.
not massive. It's not massive.
This is
It's
all. I
just,
think this is literally all it is, guys. I think the one that's annoying. There's a fifth order method that's a bit longer.
Right, okay. We were just doing what they did in the Zurich paper, right, Finn? Or was it from somewhere else?
I actually
Definitely
don't know what they're
don't-
using. as a paper.
Definitely don't like go look
Oh,
at
yeah,
like, some
yeah, that's
massive
right.
thing, because like a lot of these methods are quite simple, but they like some of this the implementations of a bunch of just garbage pre-proc macros for like all sorts of dumb
Yeah.
features you don't care about.
Right.
Yeah, no, there are a lot of these. Here, RK4 in a C version. This thing does not. Oh, here, a C version. RK4.C. Yeah, here, right here. This looks decent enough. Send this to you guys. Put it in the gen
Cool.
in the Discord. Oops. Put this in gen in Discord. RK4. This seems like this
Okay.
seems fine.
Yeah, it's not bad.
All right, cool.
Cool. Have a
I'll
look at
go-
that then. And
I'm gonna go grab some coffee so I can do this, and then what time is it? 2. So I've got 3 hours and 12. I got a meeting at 5 today. Like 3 hours to just crank on this sim. I should be able to get you guys like at
Mhm.
least something for then, and then over the next few days, the idea will be that this will get like way more stable, because obviously there's going to be a perf hit to there's going to be a perf hit initially while we're training on all these different randomized drones. The only thing I need from you guys is any errors or things that you spot in the init drone physics,
Yeah.
like the scaling walls.
We'll give it a proper look.
All right.
yeah, I was looking through that earlier. There's a couple of bits I'm not completely convinced with, but I'll
Yeah,
sit down
don't
and
assume
figure
I'm
it out
correct here.
properly.
It could be completely stupid.
Okay.
Cool. Before I hop off here, anybody else in this, because there are a whole bunch of people in voice here, anybody else here had questions or things? You can say hi. I normally don't bite unless you submit LLM slop to Pufferlib in PR. Guess not. All right. I'm hopping off of this. I will be still streaming, and yeah, we'll see if I can get you guys a thing on this, and just hit me up in the chat if you have anything to discuss.
Perfect.
Cool. We'll probably be around for another couple of hours tonight, and then we'll be back tomorrow.
Yep. Good luck with the drone. Bye.
Thanks.
Okay. You too. Bye.
Yeah, just Blizzard.
All right. Well, that was fun. Whole bunch of new people in Puffer. Holy. Yeah, look at all this. July 9th, July 10th. Look at all these people. It's a good time to remind people to start Pufferlib on GitHub. It's free and it really helps. Just star puffer.ai, star the repo, helps. Start Pufferlib. I'm going to be right back. I'm going to grab myself more coffee. And then we are going to actually finally build the sim instead of yapping all day. But we have had some pretty cool growth, so it's worth it. But I'll be right back. Don't let me forget to unmute my mic. Okay. Let's just put up the repo real quick. Oh, 2.4K. Holy. Yeah, that's some growth. That's really nice to see. Look at this. 2390. Holy. Good to see the hard work paying off a little bit. Now we will actually build some Sims. I promised this many hours ago, but now we will actually build some Sims. Sims. How bad could this possibly be, right? We have 400 lines of code here. Maybe what I do is I keep the drone swarm code. So that one's at least multi-agent, right? I already refactored that one to be multi-agent. Okay, I know what we'll do. So we do okay. Simulation properties. These get deleted, right? These are already in the main file. Compute observations is fine. It's fine. This is actually pretty clean. So all we really need is the ring buffer from here, right? So when we init this, we have to allocate the ring buffer. And that's pretty much it. Ring has a position. It's actually why don't we just zero the whole thing, right? is. Okay, so we zero out all the rings. Now the observations are going to need to be slightly different. Yeah, we need to add in the rings. We can just do the next ring, like the next one ring for now. The one ring to roll them all. Two next ring. Two per. Wait. What? How does this make any sense? Oh yeah, we're just gonna do the current ring. This. These are all of our ring observations. Q inverse. Ring buffer, ring index. It's going to be drone ring index. Definitely want this. Okay, so now we have our ring. And now let's get the plot to this ring. Heading off stream so I can focus on physics. Yeah, sounds good. You don't have to be watching this 24/7. It's just drop in when you have questions or things. I'll get it working for you. I'm not promising it'll be done today, but it will be done relatively soon. I've been pretty lazy with my streaming hours. We don't need either of these vecs, right? Yeah, we just need these two. Okay, so for drone swarm, we're going to add +6 before I forget to do this. Because I added 6 observations. It's cool. I think this is good. Now, when we do reset here, we're going to pick a task, okay? And what we're going to do is weight these. I think for now we'll just do it the simple way. Task race. And then this is going to have, whoops. All right. You have set target. If it's a race, then we need to do this generation stuff, yeah? We need to do this generation stuff. Let's see if we clean this up a little bit, because it's kind of a mess, right? Ring buffer, I-1. If. Whatever, we do this for now. For agents. Okay, something like this. So if it's a racing task, we do this. In some way, help me understand this, and how can I help you? I'm a simple, curious guy. I just released a whole bunch of material on everything I do. There's like a whole introduction to reinforcement learning and exactly like step by step on how to get up to speed and how to get involved with all of the dev. It's on X. So people always ask me that. I finally put together like a comprehensive guide, and there's a companion article if you're lacking on the fundamentals of before even you get to this. I will put my X on the in the chat. It's a much easier read than a lot of the other materials in this space as well. Like, it's designed to be fairly accessible. Yeah, of course. The hope with a lot of the educational stuff, right? Because like the stream and the content here is not educational by default. Okay, like the main thing that you're seeing here is this is advanced reinforcement learning live. Now the thing is, we've actually made it a lot easier than ever before to get into this space and to help with that. So some of the educational material now is out there to like help people get into this space and actually help us push forward all this research. Definitely to go through this, get back to you. Thank you. I mean, literally all the contributors here, like the only difference pretty much is the ones who actually stuck around and went through the material and wrote some environments have gotten good and been able to do this. I haven't had really anybody who's done that stuff and actually taken the advice I've given and not been able to do this. You have to have some basic level of programming maturity. That's the only thing I can't fix. I have my programming guide on like how to learn that stuff quicker than normal, but that's the only thing I can't just like give you the information on. You have to be able to at least write like basic low-level code and not make a mess. I say as I have like this total mess of do while. Hey, not perfect. All right, so that's gonna set the course. We gotta do the ring check, right? Yeah, we gotta do the ring check, right? Out of bounds. Yes, down here. Oh my gosh, another one of these. I love the headphones are broken bots. Hey, I couldn't pay for an LLM that does. I couldn't pay for audio captioning for my LLM. Can you please do my scam job for me? To get rid of that. One of these days I'm going to end up banning somebody who's not actually a bot, but I'm pretty sure on that one. Okay, so this is the logic we need here. Check ring. Yeah, like this, right? Delta reward. Do like this maybe? Tips on staying focused? I don't. Is the thing. I actually don't. This is not long periods of time being focused. This is me yakking around on Discord for a bit and doing like a few hours of actual work in an entire day here. Typically, what I do is I try to get good sleep, I get good exercise, I eat well. These are very important. And then I pick an interesting project that I actually want to work on. I work on it really hard for a few weeks, like 80, somewhere between 70 and 90 hours a week, until I like solve the problem and burn myself out in the process. I work like relatively normal hours, somewhere between 30 and 50 hours a week for like a few weeks until I'm like recovered, and then I do it again on another problem. I work in cycles. Honestly, the worst thing for my focus lately has just been that I've had a couple injuries that have prevented me from doing like the all the types of exercise that I'd like to do. So that's been like kind of sucky. But yeah, this is right here. Like these few weeks, I've kind of just been chilling. Oh, also, I cannot focus at all on bad code. If you make me read like over abstracted shitty code that takes forever to figure out what anything does, like I just won't. Same thing with like boring papers. I cannot force myself to read them. So part of the reason I keep things simple is because it helps other people, and it just makes the tools way better in general. But also, I literally can't work any other way because it's just boring. So. I've given advice on like how to spin up in any specific area, and like the way I suggest people to get into RL is one that's quite engaging, and you generally won't have that many problems with it, unless you try to read all the papers and like to read these papers block in a row, which I would hope it's obvious that you're not supposed to just do that. Welcome, Imagine. The streaming actually helps me stay focused as well, believe it or not. Why I do it. Because like all the time I spend talking to chat is time I'm not like spacing out staring into nothing, being bored. So it evens out. It's more fun as well. I didn't find drone flag. It's drone swarm. I'm also messing with that right now, so. But yeah, it's drone swarm. It's not on the website, but it is in Pufferlib, like the Pufferlib 3.0 source on GitHub. It is there. It's not just a flag environment, by the way. Like, they can form a sphere, they can follow a target. I just did the flag demo for 4th of July. We have way more stuff than just that. If anyone watching happens to be in drone space, we are looking for contracts. So there is business side stuff as well. I can't run Puffer from source, but can load from pip install. Well, you have to tell me, like, I can't run it. You have to tell me what that means. Okay, I had a meeting confirmed now for 4. He wants meetings today. Lovely. Set myself an alarm. We'll get it done in an hour and a half anyways. We'll have like a prototype of this working. Yeah. Okay, go to next ring. Anything else? I don't think so. I think this is the base of everything that we want here, right? I'll have to figure out like bugs and stuff, but Max Vel. Was there no Max Vel? Drone Max Vel. Oh yeah, this is not going to that's all stuff I can fine tune easily. Let's get it working first. This is agent, not drone. Q inverse is already defined apparently. It's fine. For a ring. Ring IDX. Wait, what? You know, this is fine. Ring IDX. Just forgot this. Undeclared identifier drone. This is probably agent. This is agent ring index. Oops. Episodic return. Oh, because it's the drone. So return. Matt, you gotta give me debug stuff if you want me to answer that. I can work miracles, but I can't read minds. Hey Weston, how's it going, man? We have content that you will be interested in. Check this out. This is actually perfectly suited to you. My advice for programming and ML, all my advice in one spot. Ultra opinionated guide to reinforcement learning. There you go, 25 pages of content, educational content with tons of references. Merry Christmas. First time here. NeoVim spotted. Honestly, one of the things I write in my programming guide is to not worry too much about the IDE. Like, I like NeoVim. VS Code is fine. Just don't use Cursor. All right. We'll fix that. Trying to run PufferTank 3.0. Type error. That looks like a permissioning error, man. Yeah, that looks like a permissioning error. If you want, you can try just the basic UV setup in WSL. It should work. What do you think is the right way to install Puffer, through pip or copying source from Git? So if you just want to use Pufferlib, right? If you want to use Pufferlib, the pip package has everything you need, right? If you want to dev on Pufferlib, like if you want to contribute to Pufferlib, or you're doing like custom environment work and stuff like that, you're not just like using what is there, then you either clone or ideally fork the repository. Thinking of trying NeoVim. Are the shortcuts hard? No, they're not hard to get used to. Look, literally you do this. Oops, where is it? Is this not in NeoVim? Is it like different command? Vim tutor. I haven't checked this for so long. Oh, tutor, enter. All right, so here you go. This is where they moved it to. Tutor. All right, and now it gives you everything. This is your reference. There used to be an interactive tutorial that was better. I don't know where it went. But like, I really don't have that many shortcuts I use. It's kind of just a text editor. Trying to create a few M's. Then yeah, then you use it from source. Getting the config is difficult. The stream is at the same as my X handle. It's JSuarez5341, same handle on Twitch. So I don't have a crazy config. I just don't have one. And you actually can copy mine if you want from, it's in PufferTank. My config's public. So this is all I have. I have 2 plugins, all right? I've got Super Maven, which is the single line code complete that you're seeing. And I've got Semshi, which adds some highlights because Python highlighting sucks. I've got like very basic Vim stuff here, that's it. Half this stuff I don't even care about or use. And then all the rest of this is just color scheme, all right? This is all just color scheme. That's it. This is all that's here. I used Vim with no plugins for like 7 years. It's fine. What did I break here? Oh yeah, compute observations, that's easy. Actually, if you want to try it here, so if you just go to Puffer, and you star the Puffer on your way into the here, because you should star the repo to help me for free. And then you go to here. Okay, there's PufferTank. This is the Docker, the exact Docker image I'm using for all of my development. And if you check right here, here's my Vim file. So it's included in the Docker by default, or you can just copy that one file. Ring buffer. I need to set max rings. Okay, we still have nams. Lovely. Is it the max velocity normalization or something? It's weird. Max moves, max rings. No, I didn't forget anything there. Trying UV sync. UV should work. It's giving me errors from source. Ah, lovely. So, the thing that you might have to do for that... Hang on. Try pip installing setup tools 70. Try setup tools 70. There's not much I can do about that specific one, Majid, which is why we have it set up in the container. If you try to UV from source, like there's versioning hell to pay, and it's because Python tools suck, because Python devs like sniff glue or whatever. I don't know. Can you give me a brief idea about this research? Well, that was probably a lovely entry point to this stream, but yeah, welcome. So I do all sorts of reinforcement learning work. You can see a lot of our demos on puffer.ai. We have a lot of games. We have drones. We have autonomous driving. We've got tons and tons of different work in here. It's just general purpose, really high performance simulation and reinforcement learning tools, algorithms, and the like. And I stream all the dev on it. And we have a whole bunch of people in the community who build stuff with us. Error with, no, not greater than equal to. You need to do setup tools like equals 70. If you do greater than or equal to, it'll just keep your latest version. There was a regression in setup tools that'll break stuff. All right. This is why I have the Docker, Majid, because from source, right? From source, you have to deal with Python versioning hell. And like it's technically, yes, it is possible to fix all this crap, but like, it's just not fun. It's Python. Like, you're fighting the language in their tooling. I've never seen like, I don't think there's any other language that constantly breaks their core build system for their packaging so often. Is it possible with Docker? Yes, of course. So the Docker, literally what the Docker is it's just an installation of Pufferlib that's known to work from source. That's just packaged for you. So that you don't deal with this crap. This is why I still use Docker instead of UV, right? Like, yeah, in a sane world, you'd just be able to grab UV and get your setup and everything would be good. But because Python tooling sucks, UV is often not heavy enough to actually just make your thing work. Because, oh no, you know, different setup tools version breaks the build. What is the command? It's on the website. You just clone the PufferTank repo, and then you docker sh test, and it'll just pull the Docker down for you, like the pre-built image. It'll just pull it down. It'll launch it for you, and you'll have your full Docker. It adds all our launch args, so that you can render through Docker, have access to GPUs. It's a really long run command, so we just give you the repo. What's the ultimate purpose of this stuff? You're building some application. So you can think of Puffer as a private lab. We do core research on reinforcement learning, which is just general purpose. How do we make neural nets learn through interaction with either simulators or the real world? It's a very, very broad problem space. And then we do applications either on our own or for specific companies, right, in a variety of different areas. We've done stuff in animation generation, we've done stuff in finance, we've done stuff with other research labs. You can see here we're working on some drones. Well, you can't see here because I haven't run it recently, but I'm working on drone stuff at the moment. There's stuff in logistics we're dealing with. There's stuff with other labs we're doing. There's just tons and tons and tons of different problems in autonomous learning through interaction. Issue with VS Code 1.1.0. Yeah, I think, Weston, that's not a Puffer specific issue though, right? Like that's VS Code in general, right? Yeah, so this thing has nans in it. Where's the divide by 0? Max velocity, max omega. They broke dev containers, lovely. You see why I don't like introducing tools? Like, as much as possible, I just rely on the minimal set of tools. Because it's like, oh, I'll just use VS Code. It's like everyone uses that. And then it breaks. And it's like you have to go spend your time doing that instead of working on the thing that you should be working on. So it's like I basically just assume that any tool I'm going to want to use is going to break at some point, and it's going to be a pain. And if you stack up enough of those, then you'll just spend all your time working on debugging tools. And then congratulations, you're a FANG engineer. You can collect your fat paycheck for doing nothing. Ah, I see. So this is the problem. Are you available for a Discord conversation? About what, Majid? I can hop in there for a second, but I'm going to keep working on this while I do. Do this. Show your issue? Yeah, sure. I can do that. Hey, how's it going? I don't think your mic is working. It should not be on my end. There's no green circle around you if you're talking.
Oh,
There you
you
go.
can hear me?
Yeah, now it works. Hey, how's it going?
Okay, I'm good. How are you?
Doing all right.
So it was nice discussion when everybody kind of talking about different things.
Yeah.
Okay, let me share my screen. Okay. So what? Share screen. I'm not seeing any.
What?
What? Yeah, I'm clicking on the share screen button, but it's in SD. Okay, let me, I think, close this application and reopen it.
Mhm.
For some reason, it's not showing anything.
My agency 64. So why is this still broken? Null pointer type drone. Here. Ensign char. Base colors. Oh, flag colors of I.
No, right now.
It's 64 agents. Seg fault at 322. And nearest returns null.
Are you guys hear me now?
Yeah.
Me. Is it visible?
Hang on. Let's see what you're looking at if I fix your bug real quick. Yeah. You're showing
Oh
the
yeah.
Discord
So this
application.
is.
You're only sharing the Discord application.
Oh really? I thought
You have to
I
share your
shared
screen.
the entire screen.
There's an application window.
Make selection. make a selection. Share. It says share all application Windows. This one.
Let's see. Let's see.
No, still for some reason. Entire screen. Okay, gotcha. Okay, I think now. Okay. It's visible now.
Yeah, let's see. So you have, yeah, see we're installing. Okay. So, okay, why are you installing Pufferlib Common?
I have no idea. I just do like
Is
UV
that in
sync.
the docs?
No, I mean, don't I have to build? Because
Yeah,
I
but
was trying the example.
yeah, but
And
where did you see the install Common? Common is a very heavy thing. Did you see somewhere in the docs that you should set that flag?
no, I saw like if it use the UV. So my first instinct is kind of sync to get all the missing libraries.
Does Sync just install
And
Common? If Sync just
I
automatically
think
installs Common, then that's just UV being stupid. I don't think it would do that though.
UV sync.
Well, I don't know if you have a clean environment. That what if you just UV pip install -e dot
Offer.
That should work.
-e dot
So
yeah dot like period.
okay.
If the UV devs can't even write good tools, then I don't know. Like language is a lost cause.
Yep.
It's actually installing something now.
Yeah.
Like honestly, the Python tooling is just terrible, and like they keep making it worse.
Yeah, I think like
Like Toml should not even
for some
exist.
reason, yeah, I think for some reason enterprise does not like Python for some reason.
Well, enterprise is generally
As
like terrible code in general. So I don't trust anything out of enterprise.
yeah, that's true, but you know, and probably because they don't spend that much money to Python, and that's why it's for some reason it's not generalized how you know other programming languages right now. Let's say .NET, Java, or something. Yeah, I think it's resolved my issue. Looks like yep.
Okay, can you run it? Like, can you like puffer train, puffer breakout? It's like puffer underscore breakout. BREAK.
I think I had to add something
Let's see what that does.
because it's a Mac. Yeah, I know what I had to do.
-- train
It's
dot
you know
CPU.
CPU, right?
If you don't have, yeah. in his build device.
Yep, it works fine.
Okay, there you
So
go. I don't know what I'm supposed to do about that type of stuff. If it's like UV being stupid, like I don't know why the heck it was randomly grabbing the common option out of everything. Like if it's just gonna go randomly install optionals that are way heavier and require other dependencies, then like I don't know what I'm supposed to do about that. That's like the Python ecosystem just being dumb.
Yeah, no, I understand. So one quick question, let's say I'm trying to build my own custom environment. On that case, if I use, buffer command, then do I need to put my environment inside Ocean?
Yes. If you, the reason I suggest doing it this way is because otherwise you have to handle your own C extension build system, which unless you really know what you're doing, you don't want to deal with your own C extension build system. It is incredibly painful and it's like an undocumented buggy mess, and it's because of Python. So like you're gonna fight like language level and like systems tooling level issues if you do it yourself. You can absolutely do it, but like if you make it it's a lot easier if you just basically copy our template and then do like work from there.
Yeah, because I was kind of playing around with the buffer importable.
Mhm.
It looks like I had to deal with everything from the beginning. So that's why I'm kind of
You can symlink. Look, if you really want it, like let's say that you have your own environment project, right? And you want to have it in its own repo and stuff. If you really want to, you can probably just symlink it, right? So you have your puffer install, you can probably just symlink it in Ocean. You probably still have to add like the one line to environment, but you can keep your environment code separate if you have to.
Okay, and I can use buffer command with it.
As long as it's
Right.
as long as you either have your environment or you have what should, I think a symlink in there should work just as well. Yes.
Okay. Yeah, that will make my life
We
pretty
will
easy.
eventually figure out a way to make this experience better so that you can like more easily have environments and custom places. But the thing is, like, you have to, at some point, you need to invoke an extension build system in order to get the bindings to work in Python. And that's really obnoxious, right?
No, I was kind of trying out some. So I need importable because I'm trying to do something. Let's say so every time I come here and I need to do all the commands instead of it's trying to build something as a platform. Let's say I will interact from let's say a website, and I can kind of build general purpose thing so that I don't have to do everything manually each time.
Yep.
So that's why I was looking for something that that I can integrate with APIs like Fast API or some other things like importable here. So
Yeah, you can
that's the reason I
it's
was looking at that.
absolutely all there. Like, if you're relatively new to like the RL stuff though, the easiest thing is going to be to play with stuff the way that we do it in our own development first, and then after that decide if you want to do all that other stuff, right? Like I know it's very tempting to be like, oh yeah, let me just put this into something I'm familiar with first, but like the way we do stuff in our own internal dev is very, very good for RL, and if you want to do it your own way, that's fine, but you should absolutely like understand how we're doing stuff first, because RL is not trivial, and like there are a bunch of moving parts. We've reduced it to as few moving parts as possible, but if you don't understand how those ones that are left are working together, you're not going to be in for a fun time.
Yep, that's why what I faced right now.
Yep. So
then I changed that plan and trying to understand as deep I can,
yes.
like
The more
kind of
you just
recreating existing environment what we have on Ocean,
the more you
and
just
then
do
maybe
that to
I'll
start with,
discover.
the better of a time you're gonna have, right? The entire Pufferlib source for all this that you're gonna touch is only a few thousand lines. It's a very short and succinct library. it gives you a lot of tools with not a lot of code, and you can absolutely hack on it, but you're going to have a way better time if you understand how and why we're doing stuff first, because it's not the way that you will like. It's basically not the way anybody else does stuff, and there's a very good reason for it. Right?
Understood. Yeah.
Right? Like this is not just like an out there library that does weird things for the sake of doing weird things. This is like reinforcement learning got nowhere for 10 years. We had to completely rethink how it was done in order to make everything fast, insane, and simple. That's why it is the way that it is. It looks
Yeah,
like
that,
this works
that makes
though
sense.
now.
Yeah.
Like it looks like you have this working now.
Yeah. Yeah.
Cool.
No, thank you. Thank you for your time. Yeah.
All right. Yeah. No
I really
worries.
appreciate
I'm
it.
gonna hop off of this. Right.
Okay. All right.
Okay. Looks like I gotta go take a call. I'm gonna go take a call, I think, real quick. And then I've got 2 more meetings afterwards. I'm gonna give it like another. Let me at least see if I can just fix this one last bug, and then I'll go see about my call. Why is this thing nearest? This. Okay, the intensity is nan. Max RPM, because max RPM. Oh, I don't call it drone dummy. What's wrong with this? ASAN mem copy. Do I have this right? Is it not getting, and is Nick not getting called or something? Is this not Calic? Oh, yeah, this doesn't Calic. The heck? Okay, lovely. This actually runs now. Now, can we train this on a specific task, I wonder? Oh, we need to adjust the binding file, right? Because like we added max rings. So we'll just do max rings. Oops. All right. I gotta go take a call, it turns out. So let me answer this one question real quick. I revisited my implementation of the rainbow paper and got it to work with Pufferlib. Have not tested it. What do you think I should do next? Ooh, yeah. Get it on to Pufferlib and run it on like just Pong and Breakout. Basically, just get the really basic environments working, and then we'll go next steps from there. That would be, yeah. Once you have something like that, I will jump in and I will help more. I gotta run. Yeah, I got like 3 business meetings. I'd like to be streaming more stuff, but hey, gotta grow the company. I will be back probably tomorrow. What's tomorrow? Saturday? Yeah, I'll be back tomorrow first thing with more stuff. If you like what you see, if you're new around here, yada yada, all the things. Puffer.ai. Start the repo, helps me out for free. Join Discord to get involved. Follow me on X for lots and lots of reinforcement learning content.